Hello, hi, namaskar everyone. Just give me a quick response. Am I clearly visible and audible to everyone? Can you all hear me? Can you all see me? I hope the stream is running smoothly. I am clearly audible, visible, and everything is happening smoothly. Shall we get started with today's discussion? Quickly give me in the comment box. Are you all there listening, watching, and understanding this session? Yes or no? Quickly, everyone. Quickly, all the participants. Before we get started, let me clarify the agenda for today's session. What are we going to do today? We are going to cover entire matrices for your class 12, for your class 12th, of course, along with JEE preparation. So mostly, yes, it is actually related to your JEE Mains and Advanced. But some of you may ask, sir, is it really possible to cover this chapter which holds such an importance in IDGA from JEE's perspective that every year on an average 2 to 3 questions are asked, then can it be done in one shot? I would say no. Only a fool will ask something like that. Only a fool will think something like that. I'll say theoretically we'll try to cover all the concepts in this one marathon, backlog marathon. But practically, when you talk about practicing it, consolidating it with a lot of questions and examples, there you need more practice. So right now, if you have already started preparing for JEE, if you are in class 12th, you might have missed it. Maybe either in our Lakshya batch where we have already covered it in a lot of sessions with a lot of previous year's questions, or maybe you have missed it in your school or somewhere. So if you want to do a quick revision, if you want to complete this chapter in this one shot, you have this opportunity to do this in one single session. That's the agenda of this session. Now, sir, we got your point. Now, how are we going to study this chapter? I'll say majorly, I'll take you through the theory, the formulae, all the important concepts, along with some apt, decent, appropriate examples. But what is my expectation? If you really sincerely want to consolidate this chapter, if you really want to score well from this particular chapter, in January or in April, let's say 2027, you're going to attempt JEE where you want to have a good score, then of course, what you now need to start doing is start practicing as many questions as possible from this chapter. More importantly, first of all, start with the DPPs, which you must have been getting with Lakshya JEE in English, or maybe some decent questions from wherever you are getting it, but you should get the right, apt, appropriate set of questions. Anything irrelevant will not be here sufficient. The next thing will be solve last 5 years PYQs. Let's say 2020 onwards, all the PYQs of this chapter, matrices and determinants, should be done by you. Trust me, if you have thoroughly, completely, sincerely, in an in and out manner done it, your job is done. So yes, good evening everyone. Shall we get started? Before we get started, I'd like to tell you something more interesting here. We have this feature which is called Pylons app. Sir, why are we talking about this? The beauty of Pylons application is really simple, that with this you can participate in our polls. Sir, is it just for participation in polls? No. If you want a quick summary of this session or any random session on YouTube, or let's say you want a quiz created on any random video on YouTube, you want mind maps, previous year's questions, anything from any random video on YouTube, this Pylons app works everywhere. Of course, if you want to participate in the live polls, it will be applicable for the PW videos only. But apart from that, yes, you can avail a lot of benefits of this particular application. Sir, how can we have this? You can have it from either Play Store, Google Play Store, or if you want to, watch it on your laptop, on your browser, you can download it from Chrome Store as well. What is the duration? Maybe 3 hours minimum, I'll say. I'll try to, but yes, as Tarun Kumar has already stated, minimum 3 to 4 hours I'll be taking to cover this, because it is one of those important chapters which has a lot of concepts. If I try to tell you what all we'll be covering in this session, would be this. I'll talk about formation and basics of mathematics, basic algebra, types of matrices, trace of matrix, and product of matrix. This is the first part of this chapter. Now, this is easy. This is something which you all can get very easily if you have studied determinants so far. But the interesting part, the more important part comes with this. All about different types of matrices, then adjoint, its properties, inverse, and matrix. If I were to tell you that if you were to conquer this chapter, if you want to master this chapter for JEE Mains, these are the 3 topics you should not skip at any cost. Trust me, you will anyway found minimum or exactly or at least 2 questions from these 3 topics in JEE Mains. I have already told you, Tarun, first of all, watch this session, consolidate your theory, and then do decent amount of questions from a good source, relevant questions, apt questions, appropriate questions, the way we do in our Lakshya batch, the DPPs we provide, and ultimately solve the last 5 years, previous years questions thoroughly, sincerely. Yes. With that, great, 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 great. That's good. That's good. That's brilliant. We are really proud of you. Now, with this, shall we get started? Shall we start our discussion on this particular chapter? Shall we, students? Okay, here we are. A set of mn numbers arranged in the form of fractal. Imagine your Google Sheet. Now, in Google Sheet or in Excel sheet, what you have is you have a tabular structure of rows and columns. Great. With that, you will be suggested to do advanced level problems. For that, of course, there are good resources are there, or if nothing is there, you will always focus on the previous year's questions of JEE Advanced. That is always there for you. Now, I hope you remember you see a Google sheet, an Excel sheet. What is happening there? So there are rows and columns. So if there are rows and columns, what is there in rows and columns? Data arranged in rows and columns. So a matrix, when it's put or taken care of, it is always simply an arrangement of rows and columns. Yes, 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 that's exactly RT native. So with this, let's say I have m number of rows and n number of columns. So I have a matrix of order m cross n, which has these many number of rows, these many number of columns, and here, if I were to ask you the number of elements, will it not be m into n? I hope this is something really basic and easy. So far, matrix is not a number. It does not have a value. What is it? Sir, it is an arrangement of data in rows and columns. Sir, how is it useful in mathematics? I'll tell you its applications, the real world applications in this very session only, right? So far, I hope you have gotten a decent clarity on a matrix. So in a compact form, this is how you define a matrix. Let's say there is a 3 by 3 matrix, which is denoted by capital A. So its elements are given by A11. A11 means first row, first column. Then we have A12, first row, second column. Then the third element A13, first row, third column. Then we have the next element 21, second row, first column. 22, A23, second row, third column. Then third row, first column. Third row, second column, and third row, third column. I hope you got this. So there are total 9 elements. Now, the other way of writing it is this: parenthesis over Aij m cross n. It means A11, A22, A33, A44, and so on. So this is how you write a matrix. Usually, matrices are given by or denoted by capital letters, capital A, capital B, capital C. This is how you denote matrices. Everyone comfortable with whatever is said so far? Yes or no? If I were to ask you a question, and if you want to participate in a poll, shall we conduct a poll? So this is a single choice question. You can participate in this poll and you can see your name appearing on the screen if you are genuinely and sincerely doing it without using AI. I'll be really glad and happy if you could participate in it. So I hope a question is visible to you, asked by JEE Mains in 2023. Let's see how many of you get it right with their sincere efforts, with their genuine efforts. So try solving this question, everyone. All the participants. Here we are given the number of square matrices. So this is a square matrix. What is the square matrix? The number of rows and columns will be same. Then it is of order 5. Order 5 means 5 cross 5. So there are 5 rows and 5 columns. Then it will have entries either as 0 or 1 only. So the entries will be either 0 or 1. Okay, we got it so far. Such that sum of all the elements in each row and sum of all the elements in each column has to be 1. Okay, that's a condition. So rather than calling it a question on matrices, does it not look like a question on permutation and combination? Yes or no? Be quick and answer this question, students. Quickly, quickly. So if I now start answering this question, I'll say here we have this 5 by 5 matrix because it is a square matrix. Yes or no? So if it is a 5 by 5 matrix, 1, 2, 3, 4, 5. Similarly, 1, 2, 3, 4, 5. So there will be 5 rows and 5 columns. Yes or no, everyone? Now, pay attention to this part, students. Here we are. I am told that each row and each column should have the sum as 1. So let's say this is your first row. In first row, I have kept 1 here. I have kept 1 here. Now when I have fixed this one here, do you not think that now when I talk about all the other remaining rows, I cannot keep a 1 here, because if you choose any row or any column, the sum has to be 1. The sum is mandatorily supposed to be 1. So here, if I have chosen first row, and if, let's say, for example, just to understand this, I have pushed 1 here, that means now in this column, I cannot keep 1. Because if you choose any row or any column, the sum has to be 1. It's like solving a basic puzzle, which you see in a lot of magazines, right? Now with this, if I now talk about the second row, I hope you're realizing, if I had 5 choices, to fill the first row, will I not say I am left with 4 choices to fill the second row? Because 1 cannot be filled here. That means now I am left with this, and this. Total 4 choices. Yes or no? I'll just take an example. Let's say I have pushed 1 here, which means again, I cannot keep 1 here in this first column now. Because any row or any column when taken should be giving me the sum as 1. Yes or no? With this, if I talk about the third column, will you all not say, sorry, the third row, will you all not say that, sir, it should have only 3 possible arrangements only. You should have only 3 choices for keeping 1 here in the third row. So third row has 3 choices. Just to make you understand, let's say I have placed 1 here, which means again, in this column, I cannot put 1 now. So for the fourth row, will I not say now I am left with only 2 choices? So for the fourth row, I have 2 choices. Let's say I have placed 1 here, which means I cannot place 1 here. For the fifth row, am I not left with only 1 choice? Am I not left with only 1 choice? So this is nothing but what? 5 factorial. And what is 5 factorial? We all already know this is 120. Option B should have been marked by most of you. Let's see how many of you got it right. Option B was correct. So with that, okay, RD native, that's brilliant. That's great. I'm glad you answered it correctly. That's brilliant, students. So I hope everybody got this. The explanation at least, even if you couldn't get this, even if you couldn't solve this. Now, after this explanation, are you all getting it? Are you all comfortable? Great, 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 great. Definitely. Sure, you can, you should. Now with this, let me define different types of matrices here. When somebody says row matrix or row vector, matrices are treated as vectors as well. So why vectors? When we talk about vectors, I'll tell you there. Don't worry about that. But right now, let's say if I wish to define a row matrix, it's simply nothing but what? When you have only one row. When you have only one row, but number of columns can be different. It can be 1, 2, 3, 4, 5. Let's say I am taking 6 columns, let's say. So it has elements 2, 3, -1, 0, 7, and 5. Let's say these are the 6 columns. First, second, third, fourth, fifth, sixth. So it has total 6 elements because it is 1 by 6 matrix. 1 row, 6 columns. Everybody, yes or no? Everybody, did you all get that? Or shall I repeat it, all the participants? Similarly, in the same manner, can you not define the column matrix? Okay, that's good. So when I talk about a column matrix means what? It should have only one column, which means, let's say there is one column which is fixed, but number of rows can vary. Let's say 5 rows in one column. So 2, 3, 5, -2 and 1. So these are the 5 elements, 5 into 1. Definitely shlok very soon, but don't worry about that. Everybody got this? Did you all get that? Now with this, when I move ahead towards the next category of matrices is rectangular matrix. Now when I talk about a rectangular matrix, do you not think that if there is a 4 by 3 matrix, which has number of rows and columns which are not equal, will it not be forming a shape of rectangle? And that's where and how we call it to be a rectangular matrix. But the most important one as per your syllabus is going to be the square matrix. And there, if I talk about square matrix, it always means number of rows and columns are same. In your syllabus, most of the times you'll be seeing either a 3 by 3 or a 2 by 2 matrix. Your syllabus is majorly restricted to that discussion only. Did you all get that? So if it is a 3 by 3, I hope you're understanding first column, second column, third column. First row, second row, third row. And that's how we arrange the elements, as we have just discussed in the beginning of this session only. Diagonal matrix. Now that's a very crucial matrix on which a lot of questions are asked and framed. Let me begin my discussion here. This is a matrix where the diagonal elements, if you see, where the diagonal elements, if you notice, they'll be non-zero, they'll be non-zero, but apart from the diagonal element, all the non-diagonal elements, all the non-principal diagonal elements are going to be zero. Of course, first of all, it has to be a square matrix. It is supposed to be a square matrix. But along with this, it being a square matrix, I'll be calling it a diagonal matrix if and only if its non-diagonal elements, all the non-diagonal elements are zero. So if all the non-diagonal elements are zero, I'll be calling it to be a diagonal matrix. First condition, square matrix it should be. Second condition, non-diagonal should be zero. Did you all get that? Second thing here, pay attention everyone. If I want to give you a mathematical definition here, I'll say a matrix A, which is given by Aij for n cross n. N cross n means, I hope you're noticing it, n cross n means this is a square matrix. Aij, A11, A12, A13 and so on. So these elements will be, this is Aij. So this Aij has to be zero as long as I is not equal to j. Sir, what are you trying to say by this mathematical definition? Can you re-explain? All I'm saying is, let's say this is a 3 by 3 matrix. So for a 3 by 3 matrix, please pay attention here. This is A11, A12, A13, yes or no? This is A21, A22, A23. Then the next one is A31, A32 and A33. Now you just look at this. Whenever I'm talking about the diagonal elements, 1 and 1 same, 2 and 2 same, 3 and 3 same. But all the non-diagonal elements, 1, 2, not same, 1, 3, not same, 2, 1, not same, 2, 3, not same, 3, 1, not same, 3, 2, not same. So as long as I and j are not equal, it should be 0. And other elements could be anything. I don't care about them. So technically, the definition of a diagonal matrix boils down to the simple fact that, sir, Aij is to be 0 as long as I and j are not equal. Did you all understand the very basic definition or understanding of diagonal matrix? More importantly, do you have this crystal clear picture in your mind of diagonal matrix in your brain now? Yes or no? With that, now let's move towards the next kind of a matrix, which is called scalar matrix. Scalar matrix is a subtype or more narrowed down version of a diagonal matrix only. How? Pay attention here. First of all, when you want to define a scalar matrix, you are now taking a diagonal matrix. Sir, what is the diagonal matrix? What is the diagonal matrix? Diagonal matrix here is, of course, a matrix which has principal diagonal elements. Apart from the principal diagonal elements, apart from the main diagonal elements, all the other elements to be 0. But in that diagonal matrix, if I have all the elements same, if all the principal diagonal elements are same and all the non-principal diagonal elements are 0, then we'll call it a scalar matrix. For example, look at this. Look at this. The principal diagonal elements are both 2, same each. The principal diagonal elements are all 5 each. Apart from the principal diagonal elements, all the remaining elements are 0. What does that mean? It means it is, of course, a diagonal matrix, but being more specific, I'll be calling it a scalar matrix. Did you all understand it? Now, there are different ways of writing it. In the examination hall, you may see a diagonal matrix written as diagonal 2, 2. So whenever somebody says diagonal 2, 2, it means it is a 2 by 2 matrix which has diagonal elements as 2, 2 and the remaining non-diagonal elements as 0. Everybody understood this notion, another way of representing a diagonal matrix? Yes or no, everyone? Give me a quick thumbs up. So far, is everything understandable? So far, whatever is explained, are you all getting that? Yes or no, all the participants? With this, now let's talk about a scalar matrix. I think scalar we have already discussed. It's time that we discuss an identity matrix. So let me make a simple correction here. It is supposed to be the identity matrix. So let me do that correction. Hold on for a while. This here has to be an identity, and let me make that correction here as well. So I'm now going to explain you the identity matrix, and to make it an identity matrix, there has to be one more correction. Let me do that as well. This 2 and 2 and this 5 and this 5 should be replaced by 1. So I repeat, if there is a scalar matrix, if there is a scalar matrix, that's good. And in that scalar matrix, if all the diagonal elements are 1, if all the diagonal elements are 1, then we call that matrix to be an identity matrix. Satish, I think I am supposed to answer the relevant questions, so there is no point of requesting it time and again. Skip it if I'm ignoring it, because I think I'm not the right person to answer that question. Did you get that? No. Here you have identity matrices. This is your identity matrix of order 1, identity matrix of order 2, identity matrix of order 3. So first of all, you had diagonal, then you move towards scalar, and now we are talking about identity. In the world of numbers, the way one behaves, in the world of matrices, it is the behavior or the nature of an identity matrix. If I could try and make you understand this, let's say 5 into 1 is 5. So similarly, in the world of matrices, let's say a matrix, when multiplied with an identity matrix, will give you the original matrix only. This is the nature or the behavior of the identity matrix. Don't worry about this. Once we start moving towards further part of this chapter, I'll be explaining you the nature of identity matrix and everything. But so far, are we clear on it? If I were to give you better definition of identity matrix or unit matrix, here, in a mathematical way, I'll call it if I and j are equal. So as long as I and j are equal, which means principal diagonal elements A11, A22, A33, yes or no? And if I and j are not equal, which means non-principal diagonal elements, for example, A12, A31, A23, A32, and so on. So for all the principal diagonal elements, if it is 1, for all the non-principal diagonal elements, if it is 0, then we call it to be an identity matrix. Everybody got this? Shall I move ahead from here, all the participants? Yes or no? With this, what is a singleton matrix? Yes, in the examination hall, let's say you see a matrix of order 1, which means 1 cross 1. And if it has only one element, good evening everyone, if it has only one element, then such matrix is said to be a singleton matrix. Sir, why should we remember these many terminologies? Because let's say in the examination hall, if instead of specifying that there is a matrix of order 1 cross 1, which has only one element, of course, rather than they say that this is a singleton matrix. Now, how you are supposed to interpret it, that's totally up to you. Everybody got this? Can I move ahead from here, all the participants? So singleton matrix, I hope you have gotten a decent clarity upon. Now comes one of the most important matrices, which is called a triangular matrix. This is also divided into two types, upper triangular and lower triangular. But first of all, let's get picture here of a triangular matrix. Let's say you have a matrix. Sir, first condition here is really simple. It has to be a square matrix. It has to be a square matrix, 4 by 4, 5 by 5, 3 by 3, and so on. And in that square matrix, if you see principal diagonal, now either above of it or below of it, I repeat, either above or below of principal diagonal contains all the elements to be as 0, we call it a triangular matrix. Shall I repeat that? I repeat my statement very clearly here, students. Here in this picture or in this scenario, I have this 3, 2, 7, 8 as my principal diagonal. Yes or no? So either above it or below it, if all the other elements are 0, either on these sides, either means below or above. So either of these sides means here, let's say I'm seeing all the zeros. That means with these elements, I can form a triangle, and this is called an upper triangular matrix, to be more specific. Did you get clarity on that, or shall I repeat it, all the participants? Be more specific in the comments. Have you all understood what is the meaning of upper triangular? Now, if I could give you the mathematical definition, what does it mean? I hope, again, if you look at this nature of the matrix here, let's say there is a matrix A, which is a 3 by 3 matrix. So it is A11, A12, A13. Then you have A21, A22, and then A23. Then you have A31, A32, and A33. Now, I'm just asking you to look at these numbers. Which numbers, sir? Look at these numbers. See, these 1, 1, 2, 2, 3, 3, they are great. They are same. But 2, 3, 2 is less than 3. 1, 3, 1 is less than 3. 1, 2, 1 is less than 2. So pay attention here. If I hope you're understanding here. How am I defining this matrix A? This matrix A is defined as Aij over a 3 by 3. So Aij means A11, A22, and so on. So here I'm giving you the better definition of a triangular matrix. Let's say here I'm willing to define a triangular matrix in a more specific manner. I'm saying this, that as long as I is greater than j, as long as I is greater than j, which means 2, 1, 3, 1, 3, 2. Are you getting it? These are the only three cases. These are the only three cases in which I am seeing I to be greater than j. So if I is greater than j, if it is 0, it is going to be an upper triangular matrix, because if I skip these elements which are 0 all, then apart from them, if I club these elements, they'll be forming a triangle, upper triangular. Similarly, can you now help me with the definition of a lower triangular matrix? Yes or no? What would that be, students? Sir, for a lower triangular matrix, if it is a 3 by 3 matrix, above of the principal diagonal, all the elements are supposed to be 0, which means principal diagonal and below of it will form a triangle. This is called a lower triangular matrix. Everybody got that definition, or shall I re-explain that, participants? With this, remember this conclusion here. As long as I is less than j, aij will be 0. Sir, I is less than j, what does it mean? I hope you must have noticed it here. I less than j, pay attention. Sir, 1, 2, 1, 2, I less than j, 1, 3, I less than j, 2, 3, I less than j. So if these upper three become 0, do you not think I'll get a lower triangular matrix? That's exactly what we are being told here. So tell me in the comment box, all the participants who are watching it sincerely, did you get this idea clearly? What is the meaning of upper triangular and lower triangular? What is diagonal? What is the scalar? What is identity? Do you remember that? So far our discussion is boiling down to one fact, that we are dividing or categorizing the square matrices only. So in square, if all the elements are 0 except for the principal diagonal, it is diagonal matrix. If the principal diagonal elements are all same but other are 0, it is a scalar. But if principal diagonal elements become 1, all other are 0, it is identity matrix or unit matrix. Everyone comfortably with me so far? No confusion? Can I move ahead from here? All the participants? With this, there comes a very interesting fact which is asked by JEE Mains directly. Okay. With this, if I now move ahead with this discussion, pay attention everyone, minimum number of zeros in a triangular matrix is given by this formula. Sir, how did you get this formula? Can you be more specific? Let's say this is a 3 by 3 matrix. This is a 3 by 3 matrix, which means it will have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Yes or no? Sir, we want it to be an upper triangular matrix. We want it to be an upper triangular matrix. So what is the meaning of upper triangular? Upper triangular means these elements could be anything, but the elements over here which are below the principal diagonal are mandatorily supposed to be 0. So if I were to ask you to develop the logic here, to build the logic here, so to get the minimum number of zeros in a 3 by 3 matrix so that it remains an upper triangular matrix or a triangular matrix, how will it be? Sir, first of all, if it is a 3 by 3 matrix, it will have 3 into 3, total 9 elements. If it is a 3 by 3 matrix, it will have 3 into 3, total 9 elements. Out of these 9 elements, sir, for a while, can you skip these principal diagonal elements? So out of these 9 elements, if I skip these diagonal elements, now what am I left with? So now you're left with these positioned elements 1, 2, 3, 4, 5, 6. Sir, what are they? Are they not the non-diagonal elements? These 3 and these 3. Half of them means either these 3 or these 3 are mandatorily supposed to be 0. If I want to make it a triangular matrix, then what is the basic minimum requirement here? Sir, either all these 3 become 0 or all these 3 become 0, which means what is this? This is total minus diagonal, which means this is non-diagonal. So half of non-diagonal has to be 0, and that gives you the number of minimum zeros I need to maintain in a triangular matrix. If you didn't get it, 9 minus 3, 6 by 2, 3. I need to have minimum at least 3 zeros here at these positions so that I could make it a triangular matrix. Everybody understood that definition, or shall I repeat it? Quickly, everyone. Has everyone gotten this? All the participants, are we clear on this? Yes or no? Everybody with me? Now, if I could help you in developing the formula, what will be the formula here? I hope you're realizing, sir, if it is an n by n matrix, a square matrix of order n. So the total number of elements will be n by n cross n square. And on the diagonal, on the principal diagonal, there will be n elements. I repeat, out of this n square elements, if I subtract the principal diagonal elements n, and if I half them, I hope you're realizing I'll be left with exactly these elements which I'm supposed to mandatorily keep 0 to make it a triangular matrix. So when somebody asks for the minimum number of zeros to be kept in a matrix, of course, it is not any random zeros. Those zeros are going to be placed either on this side or that side of the principal diagonal, above or below only. But if I ask you in an n by n matrix, the minimum number of zeros are going to be there. To call it a triangular matrix, it will be total minus diagonal and it's half. And this is exactly nothing but this, which is what you're given as a formula. So you don't have to memorize any formula. This question was as it is asked by JEE Mains once, and I'm just giving you a formula or a derivation on that. But I hope you got the notion, the idea, the approach, the algorithm, yes or no. With this, I'm moving towards the next category of matrices. Next is horizontal matrix. This is again a type of a rectangular matrix, in which, of course, the name itself is giving you the idea. If it is horizontal, I hope you are seeing it. Horizontal means number of columns are going to be more than number of rows. Simple, basic, easy, understandable. In the same manner, had I asked you the vertical matrix, what would be your response? We'll say, sir, if it is vertical matrix, I hope you are seeing vertical matrix. Are you not seeing vertical matrix? So vertical matrix means what? So number of rows are supposed to be more than number of columns. Everybody got this? Or shall I re-explain that? So have you gotten a decent clarity on horizontal matrix and vertical matrix? Next thing is, again, in the world of numbers, the way 0 behaves, in the world of matrices, it is the behavior of null matrix or zero matrix. Sir, what is that? We didn't get it. There is a matrix. It can be of any order. But if in this matrix, all the entries are 0, if you notice here, all the entries, diagonal, non-diagonal, rather I'll say everything. If all the entries are 0, I'll be calling it a null matrix. I'll be calling it a zero matrix. Everybody got this? Or shall I re-explain this? Yes or no, everyone? I hope no confusion on that. They are not lower triangular matrix. I need to make a correction here. I'm really sorry for that. But this has to be a null matrix. Sir, this entire session's PDF, can we have it? Yes, you can avail it. How? By joining our WhatsApp group. On our WhatsApp group, after this session, we'll upload this entire PDF for you all at absolutely no cost, at absolutely free of cost. So if you one day or someday want to revise this entire chapter matrices with one single PDF for your IDG preparation, here is that PDF. Sir, how can we have that PDF? By joining our WhatsApp channel. So where is the link? In the description. Can I move ahead from here? With this, now I'll tell you one more version, very simple version here, which is called the submatrix. It is like subset. What does it mean? If there is a matrix, and from a matrix, I have chosen certain elements. So these elements will give you the submatrix. It's like subset only. You choose few elements out of a matrix. It is called submatrix of that given matrix. Everybody clear on that? I so far was explaining you some decent standard terminologies only. Everyone comfortable with that? Now, let's talk about trace of a matrix. What do I mean by trace of a matrix here? Let's have clarity on that. Trace is merely nothing but simply sum of all the principal diagonal elements. What did I say? Let's say there is this matrix A. So if I add 2, 3 and 4, how much is that? 7 plus 2, 9. So this 9 is nothing but trace of this matrix. Isn't it absolutely beautiful and simple? So what does it mean? For a matrix, of course, it has to be what? A square matrix. So remember this, trace of a matrix if you want to find, it should be a square matrix. First of all, the basic condition here is if you want to have the trace of a matrix, it needs to be a square matrix. Everybody got that? Yes or no? All the participants, tell me honestly. Yes or no? And with that, one more condition is that if you ask me the mathematical definition, I'll say sum of AII, which means A11, A22, A33. If you add them up, you will get the trace. Yes or no? Everyone understood this mathematical definition? Yes or no, all the participants? Are you all there, listening, watching and understanding it? Now, if you have understood all what is said so far, I am now going to tell you few standard, basic, decent, straightforward properties of trace of a matrix. Great, that's good. Crocs with socks. Yes, yes, yes. I'm going to show you a question in a while, very soon. Here is going to be a question. There it comes. So before I come to that question, let me clarify a few things which are needed to solve that question. All the questions are previous year's questions of JEE Mains only. Don't worry about that. So let's first of all understand a few more properties. Let's say there is a matrix. Let's say there is a matrix A, which has elements 2, 3, -1, and let's say 7. And if I want to multiply this matrix with a scalar, then what happens? So let's say I'm writing 3 times A. So when a scalar gets multiplied, to a matrix, that scalar gets multiplied to all the elements or entries of that matrix, which means 3 into 2, it will be 6, 3 into 3, it will be 9, 3 into -1, that's -3, 3 into 7, that's 21, and with that, you get 3A. With that, what do you get? 3A. Everybody understood that, or shall I re-explain that? So, I hope you are realizing if I someday ask you the trace of 3 times of A, will you not say, sir, it will be equal to 3 times trace of A? Why? Yes. I hope you're understanding. Trace of A would have been 7 plus 2, 9. Trace of A would have been 7 plus 2, 9. And if I multiply by that 3, I hope I'll get 27. That same 27, if I take the sum of 21 and 6, I hope that also I'm getting with this. So first property, is it understood by everyone that, sir, either you multiply a matrix by a scalar first and then take its trace, or you take its trace and then you multiply it by a scalar, the value remains same. And that's a very beautiful and important property. Shall we move ahead from here? If you have gotten a decent clarity on that, now the next conclusion which we are going to discuss is going to be more amazing. Let's say there are 2 matrices which are conformable for addition or subtraction. So what do you mean by conformability? Yes, Ankit. Conformability means the order should remain same. For example, there is a matrix A which has elements 2, 3, -1 and 0. There is another matrix B which has, let me write B somewhere else, otherwise this guy will not let us do that. There is another matrix B which has elements 2, 5 and let's say 3 and -4. I hope you are understanding both of the matrices are of the same order, 2 by 2, 2 by 2. So if matrices are of the same order, you can add or subtract them, which means, let's say, if I want to find A plus B, it will be simply nothing, but you add their corresponding elements. 2 plus 2, that's 4. 3 plus 5, that's 8. -1 plus 2, that's +1. And 0 minus 4, I'm really sorry, I made a mistake. -1 plus 3, that's 2. That's 2 here. And 0 minus 4, that's -4. So this is your A plus B. Everybody understood that? Yes or no? Now if I ask you trace of A plus B, trust me, trace is such a beautiful operation that it can be distributed over addition or subtraction, which means either you find trace of A plus B or you find trace of A plus trace of B, it will be same. If you don't believe me, you do it by yourself. What is trace of A? Sir, trace of A is 2 plus 0, that is 2. What is trace of B? Trace of B is 2 minus 4, which is clearly -2. Sir, what is trace of A plus B? Sir, A plus B has 4 in -4. So trace of A plus B is 4 minus 4. And I need not tell you, both are clearly 0. Both are same. That's exactly what I'm trying to tell you. The second property here, that trace of A plus minus B is always trace of A plus minus trace of B. Everybody understood that? Did you all get this, or shall I re-explain this? All the participants. Everybody with me on this? Now, this third property, right now I'm skipping because As of now, you don't know the matrix multiplication, which I'll explain you, don't worry about that. But right now, I'm just giving you it here in your notes because we are discussing trace. But once we are done with the product of matrices, you yourself will eventually be in a position to state, let's say this property is true. Let me write its correct version first of all. This is its incorrect version. Trace of AB is given by trace of B times trace of A, or rather it is equal to trace of B as well, because there is no problem with that. I'll tell you why. It is absolutely correct. It is absolutely fine. But if you say that trace can be distributed over product, which means trace of AB can be written as trace of A into trace of B, then it is false. Sir, whatever you are saying is absolutely non-understandable. Yes, I get this. Product of matrices you don't know yet, so skip it for a while. Once we are done with product, you will start understanding it. But right now, I am willing to tell you one more very interesting fact, that here, if I take transpose, sir, what is transpose? I hope from or before studying matrices, you have gone through determinants. Have you not? So if you know determinants, there we discussed transpose. Let's say there is a matrix A, which is given by 2, 3, minus 1, 5, right? So its transpose is given by its rows and columns interchanged, which means first row is 2, 3, it becomes first column. Second row is minus 1, 5, it becomes second column. Now, please pay attention, everyone. When I ask you trace of A, what will you tell me? Sir, it is 2 plus 5. Yes or no? When I ask you trace of transpose of A means rows and columns are interchanged. 2 plus 5, that's again 7. Everybody got this? Yes or no? So always remember this conclusion, that trace of a matrix or its transpose is always same. Yes or no? Can somebody quickly tell me that, sir, why is it true? Trace of an identity matrix is always n if it is of order n, because on the diagonal it has all ones. So let's say if it is a 3 by 3, so 3 ones, so 3 times 1 is added is 3. Yes or no? So that property I hope is absolutely understandable. This you will understand once we do matrix multiplication. So the remaining properties skip as of now. But so far whatever we have done, are you comfortable with that? Now there comes a very interesting property which I could explain you later, but I'll give you the statement here. Let's say I am multiplying 3 matrices, A, B and C. Sir, how we multiply matrices? Right now we don't know that. But let's say I did it and I am wanting you to find its determinant. I hope you remember, in determinants we know that determinant of a square matrix can be taken. Let's say it has elements 2, 3, minus 1 and 5. So its determinant can be found. Yes or no? So determinant of a square matrix can be found. I hope you know how to do that. 2 into 5, 10, minus 1 into 3, that is plus 3. So 10 plus 3 is 13. Yes or no? So whether you are multiplying 3 matrices and then you are taking its determinant, or you individually find determinant A, determinant of B and determinant of C, and then you multiply them, the result is going to be same. First of all, this sign here is not a sign of modulus. This sign here is representing you or giving you the sign of determinants. And what does it mean? It means that determinant is such a beautiful operation over multiplication that whether you take the product of matrices first and then you find its determinant, or you find their individual determinants and then take the product, the result is same. Did you understand that, or shall I repeat it? All the participants, yes or no? Now this particular property is a very beautiful one and it has its own applications, and if you know it, you will be solving a lot of questions with a lot of ease. Sir, what is this property? This property is again a very, very, very insightful one. Let me tell you how. Let's have a look at that. The next property is about, let's say there is a matrix A, right? There is a matrix A, which is, let's say 1, 2, 4 and 3. This is a matrix A. Yes or no? Now, let's say I'm multiplying this matrix A by 3 or 2, whatever number. So I'm multiplying this matrix A by 3. So this is 3A. So what is 3A, sir? If a matrix is multiplied by a scalar, that scalar is multiplied to all of its elements. So 3 into 1, that's 3. 3 into 2, that's 6. 3 into 4, that's 12. And 3 into 3, That's clearly 9. Yes or no? Or if I don't write it like this, can I keep this as 3 into 1 like this, 3 into 2 like this, 3 into 4 like this, and 3 into 3 like this? Yes or no? Can I do so? Yes or no? All the participants, everybody with me. Now, let's say, sir, you are not asked this, rather, you're asked to figure out something else. What is that? Let's talk about that as well. Let's say you are asked to find the determinant of A. You need to find the determinant of A. So that's simple. Sir, we know 3 minus 6. What is it? It is clearly minus 3. You know how to find the determinant of a square matrix, don't you? Now, here, let's say I am told to find the determinant of this square matrix. Now, let's say a scalar is multiplied to a matrix, then that scalar gets multiplied to all of its elements. Yes or no? But if there is a common entity in a determinant, then I can take it common, either row wise or column wise. Do you remember that as a fact? In determinants, you must have studied it. So this 3 and this 3, let's say I'm taking common out of it, which means what? 3 times determinant of 1 and 2 in the first row. And then this 3 and this 3 I'm taking common from the second row. Then I'm left with this another 4 and 3. So if one more 3 I have taken out, it is nothing but what? 3 square. All the participants, be very genuine and honest. Have you all understood how did I get this 3 square? Yes or no? Yes or no? With this, I am giving you a simple verdict that if 1, 2, 4, 3 was determinant of A, so is it simply not 3 square times determinant of A, which will be 3 square into minus 3? Yes or no, everyone, all the participants? Sir, what are you trying to say here? I am trying to give you a very simple conclusion. Let's say if a matrix is multiplied by a scalar and then you are taking its determinant, then it is always equal to that determinant of that matrix A into that scalar raised to the power n, where n is the order of that matrix. I hope that same thing you must have started noticing here. If it was determinant of 3a, so I got 3 square times determinant of a. Yes or no? And here is your proof. Yes or no, all the participants, everybody got this? Everybody with me on this? So far, I hope there is no confusion on whatever is explained so far. Now, sir, if I am told that two matrices are equal, when does that happen? Let's say there are two matrices which are said to be equal. So here I have a matrix X, Y, Z, W, and there are elements minus 1, 2, 4, and minus 5. And I'm told that they are equal. I will be really happy in saying that they are equal if two conditions are checked. First, they should be of the same order. If it is 2 by 2, this should also be 2 by 2. Second, if they are said to be equal, their corresponding elements are same, which means X should be minus 1, Y should be 2, Z should be 4, and W should be minus 5. If something like that is happening, I'll say the matrices are equal. Isn't the determinant value minus 5? For which one? For which one? Is this one? Oh yes, I did not notice it. Thank you so much for being so attentive and alert. I took it as 6. I'm really sorry. So 3 minus 8, that is minus 5. I'm really sorry. So here also it should be 3 square into minus 5. A very good observation. RT native, that's brilliant. And I'm sure you are attending it with a lot of sincerity. And that shows your commitment. Very good. Keep it up. Have you all gotten this? Have you all understood this? Equality of two matrices, which means what? Sir, first of all, their order should be same. Second thing, their corresponding elements should be exactly same. If something like that is happening, we say matrices are same. Now, how do we add the two matrices? We have just discussed. I think I don't have to explain it. And with that, there comes another question for the day. It is again MCQ. I am starting a poll. You have this feature of pylons installed in your application. You can participate with it. If you want to install this, you can download it from Google Play Store or from the Chrome Store if you're watching it on the browser. If you want all of these notes at absolutely free of cost, then you can have it by following our WhatsApp channel. Right after this session, we'll give you the entire PDF of these notes on our WhatsApp channel with no cost. Read the name of the channel. It is PWJ English. So we are supposed to teach you specifically in English. That's good, RT Native. So let's get started with this question. I have already started the poll. You can participate in it. You can download the notes. You can get the mind maps for free. You can create a quiz on it. You can download short notes on it. You can create or get PYQs from this topic by having pylons at absolutely free of cost. That's the beauty of this application. I'm told A plus 2B. So there is a matrix A, there is a matrix B. So A plus 2B is this. 2A minus B. So there is a matrix A, there is a matrix B. So 2A minus B is this. Okay, great. Then they are asking you the value of trace of A minus trace of B. Okay, that's brilliant. Here I'm telling you, sir, what will be trace of A plus 2B? Can you help me with that? Can somebody quickly help me with trace of A plus 2B? Sir, trace of A plus 2B. Trace of A plus 2B will be 1 minus 3, 1. So 1 plus 1, 2. 2 minus 3 is minus 1. So I got this, yes or no? But what we know is, so trace is such a beautiful operation that it can be distributed over addition, which means I can write it as trace of A plus trace of 2B, and 2 is a scalar, can be kept out. So I can write it like this is equal to minus 1. Everybody got this? Or shall I re-explain this? Trace of A plus 2 times trace of B. Trace is such a simple, straightforward, sorted operation. Now, if I talk about trace of 2A minus B, if I talk about trace of 2A minus B, what would that be? 2 minus 1, 2. So it is 4 minus 1, that's 3. And again, I'll apply the same distribution here, that if 2A minus B, if I distribute this trace, so trace of 2A, so 2 times trace of A minus trace of B, that we have gotten as 3. Yes or no? Everybody got this? Yes or no? All the participants. Now, there we are with our next part. Sir, I need trace of A and trace of B. So one thing I'm going to do, I'll multiply this whole equation by 2 on both the sides. How? If I multiply it by 2 on both the sides, this 2 into 2 will be 4. This minus 1 into 2 will be 2. And this 3 into 2 will be 6. Linear equation, substitution and elimination, if you know, that's what I'm applying. If I add both of these equations, 2 times trace of B, 2 times trace of B are cancelled. 4 plus 1, that is 5 times trace of A, I get as 6 minus 1, which is 5. So here I conclude trace of A is 5 by 5, that is 1. Without even solving these two matrices, we are in a position to conclude what is trace of A, yes or no? Now, if I put this value trace of A as 1 here, 1, minus 1, minus 1, minus 1, minus 2 by 2 is minus 1. So I am reaching to another conclusion that trace of B will be minus 1. Shall I redo it, or did you all get this? Trace of A replaced as 1, 1 goes to the other side, minus 2 divided by 2 is minus 1. So trace of B we receive as minus 1. Sir, what is the question? The question is trace of A minus trace of B. Trace of A is 1, trace of B is minus 1. So the answer should be 2. And you must have marked option B by now. Everyone, yes or no? Let's see how many of you got this option B. I am sure most of you must have marked it. So we have 2 students who have participated in it, RD Native and Harsha. And I'm glad both of you marked it correctly. And I'm sure you did not cheat. You did not use AI. Great, brilliant. That's perfect. Now, with this, I hope you got some decent clarity on trace, addition of matrices, comparison of two matrices, confirmability of two matrices in terms of addition, subtraction, or comparison. When a scalar is multiplied to a matrix, what happens to its elements? Are you aware of that? When a scalar is multiplied to a matrix, what happens to its determinant? You are aware of that formula. Third thing, whether you multiply few matrices and then take determinant, or take their individual determinants and then multiply. That is same. Everyone comfortable with these results so far, which we have discussed? Yes or no? All the participants. Can I move ahead from here if you have gotten some decent clarity? Now, this is what I was talking about, that if there is a scalar, there is a matrix, let's say X, which has elements A, B, C, D. Let me create it like this only. So if I want to multiply this X by K, if a scalar gets multiplied to a matrix, we already know that that scalar is multiplied to all of its elements, which means it is going to be Ka, Kb, Kc and Kd, yes or no? But what if I want to take its determinant? Determinant of x will be determinant of A, B, C, D, yes or no? Yes or no? But if I want to find the determinant of kx, if I want to find the determinant of kx, it will be determinant of Ka, Kb, Kc, Kd, yes or no? Which means what? K I can take common from the first row and second row, so which means twice K is taken common, and then I'm left with A, B, C, D. What is A, B, C, D's determinant? That's determinant of x. So I get K to the power 2 determinant of x. That's exactly nothing but Kx determinant. That's what I'm trying to tell you. You could have done that alternative, but was that not more time consuming? Did you not find this method very quick, very efficient? Very good, very good, very good, brilliant. With this, I'll move towards few properties related to multiplication of matrix with a scalar. The first one, if you are observant enough, if you are simply understanding this logically, will you all not conclude, sir, addition of two matrices is being done and then you're multiplying it by a scalar, or rather you multiply them by a scalar individually and add them up. It will be same. It's standard, decent and self-explanatory. Yes or no? Second property. Sir, two scalars are added or those two scalars are multiplied to that matrix and then those two matrices are added. It will give you the same output. Yes or no, everyone? The next result. I hope with the scalars, they are commutative in terms of product. So K into L into a matrix A, or L into K into that matrix A, or K into L, whatever order you are taking into that matrix A, because the scalars when multiplied give the same product and that product into that matrix will always be same. Is my language understandable, students? Are you getting what I'm saying here? Everyone, all the participants. The next thing is either you multiply a matrix by minus K or minus of K or K of minus A, it will be same. Is it not self-explanatory? Is it not simple? I hope I need not even explain that. So I hope with the scalar, multiplication with the matrices is simple. But there comes the most interesting part. Yes, that's exactly what I was telling you, alternative. Had you been aware of the properties of trace, you would have done it more quickly. And that's my motive of this session. We know a lot of questions. We can do those questions. We know the concepts. We can do those questions. But what does JEE Main Advanced want? They want you to be quick. They want you to be efficient. They want you to be effective. And that efficiency and effectiveness comes with a lot of conceptual clarity, with more in-depth awareness. So the more properties, the more laws, the more rules you are aware of, you can very easily and quickly solve questions. Like you have more weapons, you have more tools with you. Abraham Lincoln has once said, if I have 6 hours to cut down a tree, I'll spend the first 4 hours in sharpening the saw. So when you have more tools, when you have more, knowledge, when you have more awareness, you are already, you're already having that saw sharpened. You are already ahead with a lot of great tools. So if you're already there with a lot of great tools, you will be solving a lot of questions with a lot of ease, with a lot of efficacy. That's my point. Okay, so you think that whatever the size of that batch is, the number of students even I'm not aware of because there are a lot. So technically we are focused on everyone. We take care of everyone. So total number of students, all the address, all the doubts, all the concerns, all the queries are resolved. Whatever concerns, queries you have. You watch one of our sessions, you will understand it. With this, I am now going to explain you the matrix multiplication. Hitain, have I answered your query? Whatever the number of students are, we answer all the concerns and queries, whatever issues you have. Now, if anybody from Lakshya is attending it right now, they may justify it. They may vouch for it. So there are two matrices, let's say for a while. There is matrix A and there is matrix B. Let's say the matrix A has a order 3 by 2. Matrix B has an order 2 by 3. So first of all, tell me, what is 3 by 2 and 2 by 3? So the matrix A is of the order 3 by 2. So there are two matrices, matrix A which has order 3 by 2 and matrix B which is of order 2 by 3, and I'm wanting to multiply them. So can we multiply them? How do we multiply them? That all I'll tell you, don't worry, step by step. But have patience, it takes time. So here, 3 by 2, it means 3 rows and 2 columns. So 3 rows and 2 columns. So let's say 3, 2, minus 1, 0, 5, and then 6, 2. So this is 3 rows and 2 columns. 2 by 3, which means 2 rows but 3 columns. So there will be 2 rows. My name is Deependra. So there are 2 rows and 3 columns. So 2 rows and 3 columns means what? I hope you're getting it. Let's say 2, 3, 5, and 1, 7, 4. So these are the 2 rows and 3 columns. Sir, if you want to multiply these matrices, what is the prerequisite? So confirmability for matrix multiplication, we call it. What does it mean? It means that this 2 and this 2 should be same. What does it mean? The number of columns with A and the number of rows with A, if they are same, they are confirmable for matrix multiplication, which means A into B is possible. And by saying so, you must have already understood, sir, now if A into B is going to be this, B into A could be something different, or even B into A is possible or not, that's a different scenario. So now you have started understanding, I'm thinking or hoping or believing that matrix multiplication is not commutative, which means if A into B is there, then B into A is not necessarily going to be same. Sir, Lakshya JEE 2027 batch students are present in your class. Okay, that's great. So Alok, are you from Lakshya only? That's great. I used to teach Astha. Now I'm here with you. Everybody understood this, or shall I re-explain this part? All the participants. Now I'm getting back to my discussion. First of all, you need to verify that number of columns here and number of rows here should be same. So we call it pre-multiplication by A or post-multiplication by B. So B is getting pre-multiplied by A and A is getting post-multiplied by B. Or in a simpler language, A is the pre-factor, B is the post-factor, left and right. So in matrix multiplication, the order matters. You just cannot say AB and BA are going to be same. The way we do with numbers, 2 into 3, 3 into 2 is same. But when matrices, no, it's not true. Commutative, they are not. Able to digest my statement, yes or no, everyone? With this, my friend, you need to read the language, you need to read the title or heading or the name of this channel, which is PW JEE English. So we are supposed to teach you in pure, full-fledged English. With this, if I get back to the discussion we all are having, pay attention to this, students. The final outcome which I'm going to get, the product AB I'm to get, is going to be of the order 3 by 3. The final product which you are going to get is going to be of the order 3 by 3, which means if these two decide whether product is possible or not, then the remaining two decide what is going to be the product's order. Have you understood my statement? Now, so you have said everything except for the multiplication. How do we do that? We are going to discuss that only. So if I now want to talk about AB, how does that happen, that product AB? So sir, I now know that it is going to be a 3 by 3. It is going to be a 3 by 3. So there will be 3 rows and 3 columns. But how? Okay, let's talk about that. So the idea is really simple. I'll choose a row from here and a column from here. I'll choose a row from here and column from here. So how do we multiply that? Pay attention here. This 2 into this 2, that's 4. Then this minus 1 into 1, that is minus 1. So this is what or how I write it as 4 minus 1. The first element. Everybody got this? Now, I'll keep this row only, but now I will choose this column. With this, pay attention everyone. 2 into 3, are you noticing, is going to be 6. Minus 1 into 7, that is going to be minus 7. It will be my first row, second column element. Getting it, everyone? Now, moving ahead, I will shift it to the third column. I'll shift it to the third column where I'll still stick to the first row, but I'll multiply it with the third column. So to get the first row, third column element, which means here, 2 into 5, that is going to be 10. 2 into 5, that is going to be 10. And this minus 1 into 4 is going to be minus 4. So this is how I define the first row elements. No, Alok, you don't call a square matrix a determinant. No, matrices are different, determinants are different. Determinant is a value associated to a square matrix, but square matrix is an arrangement of rows and columns. Great, that's brilliant. I'm really proud of you. I repeat, there is a matrix A, which is a square matrix of order 2. So 2, 1, minus 1, 0. So this is a matrix. It's an arrangement of rows and columns. So there, you simply don't have a value of this matrix. It's simply an arrangement of rows and columns. It's just data put in rows and columns. But if I ask you the value of determinant of A, so this is a matrix A and this is determinant of A, which is given by 2 into 0 minus 1 into minus 1. So the value of the determinant is 1. So of course, we can find the determinant of a square matrix only, but this is a square matrix and this is its determinant. So I hope nobody is confused with the difference between matrices and determinants. They are different. Determinant is an operation on square matrices. Just like addition, subtraction, multiplication, we take determinant of a matrix. Got my language? I'll come back to this. Now, after multiplying first row with all these 3 columns, I'll move to the second row and again I'll multiply this with all the 3 columns. So what does it mean? It means 0 into 2, that's 0. 5 into 1, that's 5. So I'll add these products. I hope you're getting it. Yes, definitely. Now 0, 5 with this 3, 7. So 0 into 3, that's again 0. 5 into 7, that's 35 and I'll add them up. Getting it or not everyone now? 0, 5 with 5, 4. So 0 into 5, that's again 0. But 5 into 4, that's 20. I'll add it up. So that's how I got the second rows, all the 3 columns. Now, if I move towards the third row here, so again I'll do the same thing. This third row, I'll multiply with column 1, column 2, column 3. I hope you are now more comfortable with matrix multiplication. Yes or no? I hope here 6 into 2, that is 12, and 2 into 1, that is 2. Then 6 into 3, that is 18, and 2 into 7, that is 14. 6 into 5, that is 30, and 2 into 4, that is 8. Everybody got this? Hitain, when I explain that, could you re-ask me again? And there I'll explain that. Is that okay? Because if I answer your doubt, I may distract students from the current discussion and that may hamper their understanding. So can we do that later when we study symmetric matrix? Will that be okay if I do that there? You re-ask it and then I'll definitely clarify that. Will that be okay? Yes, I'm taking previous year's questions only if you have been watching it so far. I'm taking a topic, then a previous year question relevant to it, and that's how we are moving further. Now, if I now wish to write the final product AB, I'll be saying it will be 4 minus 1, that's 3. 6 minus 7, that's minus 1. 10 minus 4, that's 6. It is 5 here. This is 35 here. This gives you 20 here. Then this gives you 14 here. This gives you 18 plus 14, 22, 32. And this gives you 38. So that is going to be the final product. And I hope you are clearly realizing it is a 3 by 3. All the participants who are watching it sincerely, tell me honestly, have you understood the matrix multiplication? Have you all understood how do we do it? Have you understood the prerequisite that just said this condition should be matched, then only the matrix multiplication will be possible. The next condition, sir, what will be the output of a matrix multiplication? That also can be predicted if you know the order of the matrices. So all what is said so far or explained so far, is it understood by everyone? Yes or no? I'll come back to the discussion, everyone. Pay attention here. This is what I was talking about, that A and B are 2 matrices which are said to be conformable for the product AB. So if I want to find the product AB, first of all, the number of columns of A should be equal to the number of rows in B. If that is happening, then we say that matrix multiplication is possible. Matrix multiplication is conformable. Thank you so much, RT Native. Thank you so much. We'll definitely take a break in 5 to 10 minutes. Then we'll resume. Otherwise non-conformable, and that means the product is not possible. The next thing is, if AB is defined only when number of columns in A are equal to number of rows in B. Harshit, if 2 matrices are said to be same, then their elements are supposed to be same. corresponding elements. I hope that is exactly what you were asking for. So I hope so far now you must have gotten this clarity. Sir, is it not, it is not necessary that AB and BA are always going to exist and they are going to be same. No, it is not necessarily true. Are you getting this notion? Yes or no? I'll give you this example only where I think we had A as I think 3 by 2 matrix and B as 2 by 3 matrix. Now, when I multiplied AB, I checked this thing that, sir, this and this are same. Yes, product is possible. And when I finally find the product, it will have the order 3 by 3. Did you all get that? But, sir, if I find BA, so BA means what? Sir, B was of the order 2 by 3. A was of the order 3 by 2. So beautifully or luckily or coincidentally, here this 3 and this 3 are same, which means the product BA is also possible. But this already tells you the difference that the product BA will be found of the order 2 by 2, which means, I hope you are noticing it. BA is 2 by 2, AB is 3 by 3. Clearly not equal. Great, great, great. Sapna, from matrices and determinants, if they are clubbed together, of course, they are interrelated. I need not explain that. On an average, minimum, I am saying minimum, I am saying at least 2 to 3 questions are asked in JEE Mains only. So I hope I need not tell you whether it is high weightage or low weightage. 12 marks. 12 marks in mathematics section is not something really easy. Math by nature for IDJ is absolutely tough, difficult, lengthy, and getting 12 from just one chapter is, of course, something magical in JEE Mains. Yes or no? Everyone must agree with that. Let's solve a question asked by JEE Mains this year only, and let's see how many of you are able to do it. Meanwhile, I'll take a 10 minutes break. So this is right now 8:10. We'll resume at 8:20. So there is a break of 10 minutes. We will resume this class at 8:20. Is that okay? Take a break, have some water, stretch yourself, and then come back at 8:20. And then we'll start discussing it. But I'm already starting a poll. And let's see how many of you get the answer to this question. Okay, so the poll is on the way. Here it is. So let's see how many of you get the answer to this. Okay, let's meet after 10 minutes. Take a break, drink some water. Take a break, Alok. Take a break. Take a 10 minutes break.
आती है।
Okay, so here we are back again with our discussion. Again, a very beautiful question, and I'm sure most of you must have already done it, participated in it, and let's see how many of you got it right. Shall we do it? I welcome you all, everyone. Come back if you can hear my voice. If you're roaming around somewhere in your room, now get back, sit on your table at your desk, and start watching this again with the utmost focus. Okay, little star, I got it. We'll validate it. Let's quickly start doing it. So first of all, what are we told in this question, sir? There is a 3 by 3 matrix, okay, such that M multiplied with 100 is 123, M multiplied with 010 is 012, and M multiplied with 001 is -111. If you could notice something really beautiful and interesting, your job would have been absolutely done. Sir, what do you mean by that? Okay, no worries with that. I'll say what I'm trying to do here is something really stunning. You just pay attention here. Look at this. I'm assuming M to be something as any matrix. You can take it as any matrix. So if I want to take it as any matrix, let's say it is A, B, C, D, E, F, G, H, I, because I am told that it is a 3 by 3 matrix. Yes or no? Now, how long the class is going to be? Yes, I'm going to tell you that only how to solve this. The class may get stretched till 10 o'clock. I hope that's fine, everyone, because we are going to cover this entire chapter in this one session. So theory, questions, that's how things will keep happening. But of course, questions I'll not be doing much because I want to cover this entire chapter in this one marathon only. But to consolidate this, if you have the theory with you, if you have the concepts with you, you can start practicing the questions by yourself. In the Lakshya batch, you will get all these sessions systematically organized for you, the entire chapter. I'm sure you're already watching it there if you're a part of Lakshya. So this is your matrix M. Let me do it here. Pay attention, everyone. If I, let's say, multiply M by this 100, what will you get? I hope everybody must have noticed if you're multiplying M with this 100, the product is said to be 123. The product is said to be 123. Now you tell me, what do you gain by out of this? I hope everybody is realizing that here, what I'll do here is I'll choose a row from here and a column from here. So matrix multiplication is absolutely possible. Why? Because this is 3 by 3, this is 3 by 1. So this 3 and this 3 are same, and product has to be of the order 3 by 1. Yes, that's exactly what we are given. So it is all in sync. Yes or no? Which means ABC, if multiplied with 100, it will give me A. Yes or no? Yes or no? ABC when multiplied with 100, A 00. So DEF when multiplied with 100 will give me D. And GHI when multiplied with 100 will give me G. So I think I got ADG, which means I got the first column, which is 1, 2, 3. So if I were to write the matrix M, I have gotten the first column as 1, 2, 3. Yes or no, everyone? Did you all get this? Now, shall I do it with the next one? Next one is what? M with 0, 1, 0. So M with 0, 1, 0. I hope so far you all must have already built the logic. Even if you are confused, I'll do it here. The next one is 0, 1, 0, 0, 1, 2. No, I don't teach in Power Batch as of now. I teach in JEE English, Arjuna and Lakshya for you all. Now, here I am going to tell you what is it going to be. Again, if I do this, ABC with 0, 1, 0, is it not going to be B? Is it not going to be B? DEF with 0, 1, 0, is it not going to be E? Yes or no? The same. GHI with 0, 1, 0 is going to be H. So I'm sincerely apologizing who are constantly asking me to speak in Hindi. I'm not supposed to, because this is PWJ English where we teach in pure full-fledged English. Really sorry for that. Now, if I try and tell you the matrix equality B, E, H, so I think I have cracked the second column, which is going to be 0, 1, 2. Yes or no? So I think by looking at this only, you must be able to conclude 0, 1, 2. That's your second column. Yes or no? B, E, H. That is 0, 1, 2. It will feel like Shahid Kapoor in the movie Chup Chup Ke speaking all of a sudden after being silent for so long. So let's avoid doing that stuff here. Let's stay focused on our content which we are supposed to deliver. Let me talk about the final operation. The next one is M with 0, 0, 1. So 0, 0, 1. When it is multiplied with this, you get -1, 1, 1. So I hope now you must have developed this logic. ABC with 0, 0, 1 will give you C as the first element. DEF with 0, 0, 1 will give you F here. Yes or no? All the participants getting it or not, everyone? GHI when multiplied with 0, 0, 1, GHI. So I'll be left with I only. So with that, I think I got third column as minus 1, 1, 1. Yes or no? So my third column here will be minus 1, 1. Yes or no? Yes or no? So I think we have cracked the matrix M, but the job is not done yet. The question has just started. Now, next, what is supposed to be done is, sir, this M when multiplied with X, Y, Z. So this is your matrix M, okay. So this matrix M when multiplied with X, Y, Z is giving you a constant matrix which is 1, 7, 11, which is 1, 7, 11. Now, all that can be done with adjoint as well, which you don't know yet. It can be done with the inverse of a matrix as well, which you don't know yet. So let me use a simpler method here. So what is that method? Pay attention, everyone. Rows I'll choose from here. Columns I'll choose from here. Yes or no? So 1 into X, 0 into Y, minus 1 into Z. So first entry will be X minus Z. Yes or no? Yes or no? Second row, first column. So this will be 2X plus Y plus Z. So it will be 2X plus Y plus Z. Then third row, first column. So it will be 3X plus 2Y plus Z. So it will be 3X plus what? 2Y plus Z. Yes or no? And with matrix equality, I hope you are understanding this is equal to this. So I think I got three equations now. I got three equations now. Which three equations? Sir, first equation, X minus Z is equal to 1. Yes or no? Sir, second equation, 2X plus Y plus Z is equal to what? Is equal to 7. Sir, the next equation, 3X plus 2Y plus Z is equal to what? Is equal to 11. So these are the three equations you have gotten, three variables you have gotten. If you know inverse of a matrix, you can do it with inverse as well, but I'll say it is really simple, even if you solve it with the simple approaches which you might have learnt till 10th standard. What was that? Three equations, three variables. How do we solve that? Simply either substitution or elimination. So if I add these two, Z and Z are eliminated, 2X plus X, that gives you 3X, and Y is there as Y, and 7 plus 1 is 8. Similarly, if I add first and third, so 3X plus X, that I'll receive as 4X, 2Y is there as it is, so that is plus 2Y, and again Z plus Z are cancelled, 11 plus 1 is 12, and if I cancel it by 2, this becomes what? 2X, this becomes Y, and this becomes 6. Yes or no? Everybody got that? I hope there is no confusion on that. Now here, if I do one more thing, that if I subtract this from this, so 3X minus 2X leaves you with X, Y and Y are cancelled, 8 minus 6 leaves you with the 2. So I got X. Yes or no? Once you have cracked X, you put that X here. So 2 into 2, 4. 6 minus 4 is 2. So I crack Y as 2. I repeat, 4, 6, 2. Yes or no? If I have X, which is 2, if I take it there, 1 minus 2 is minus 1. Minus of Z is minus 1. So I think Z is going to be plus 1. Now, if somebody asks you X plus Y plus Z, that has to be 5. Option B, and I'm sure most of you must have marked option B. Yes or no? Nobody responded. What happened all of a sudden? Some of you were already participating in this. Nobody? Why? Everybody got this? Everybody understood the whole explanation? Yes or no? Now, if I talk about matrix multiplication and its properties, the first property here was really simple. Multiplication of matrices is not commutative, as we have just discussed. It is not necessary that AB and BA are equal. Next thing is, if A and B, let me rewrite it, this has to be B. If A and B are diagonal matrices, if A and B are diagonal matrices of same order, if A and B are diagonal matrices of same order, then you would see it to be happening that AB and BA are going to be same. Thank you so much, Alok. Thank you so much for your such valuable feedback and appreciation. We really appreciate it. Thank you so much for your kind words. Everybody understood this? Or shall I re-explain this? What did I just say? There is a matrix A, which is a diagonal matrix. There is a matrix B, which is also a diagonal matrix. And if matrix A and matrix B are multiplied, then whether you find AB or BA, it is going to be same. So we already told you matrix multiplication is not commutative. Thank you so much, Gully Cricket. But still, if they are diagonal of same order, then they'll be found to be same. So remember this. Let's say in a question, I am told that JEE Mains and Advanced, how do they play with your brain? Let me tell you that. In a question, they will tell you that AB and BA are same. And they give you certain more details about that. Then you may come up or go ahead with this conclusion or with this assumption that they could be diagonal. Did you get my point? Did you understand my statement? Are you understanding how are they going to check your understanding of these nuances, these basics? Sapna, if you got the correct answer, to participate in the polls, the application is PyLens. You just need to download it from Google Play Store or from Chrome Store, and then you can start participating in it. It's not merely for participating in the polls. Let's say you're watching any random video on YouTube. You want short notes on it. You want PYQs on it. You want mind map on it. Absolutely free of cost. Everything will be generated for you in PDF or in other some format, and it will be delivered to you. That's the beauty of this application, PyLens. Yes, I remember everyone. Thank you so much for being such a consistent students of ours. Great. Now, matrix multiplication is associative only if conformability is there. Conformability means the product should be possible. Product should be possible, I hope you remember, AB, which means number of columns in A should be equal to number of rows in B. So if that matrix multiplication conformability is there, then whether you multiply B and C first and then you pre-multiply it by A, or you multiply A and B first and then you post-multiply it by C, it will be same. Just need to ensure that the order doesn't change, ABC, ABC. But whichever you multiply first, it doesn't matter. Pre and post you should take care of, order should matter, and conformability should be there, which means matrix multiplication should be possible. All the participants who are watching it sincerely in the comment box, tell me, did you understand this property, associativeness of matrix multiplication, or shall I re-explain that? Everyone, tell me honestly. Shall I go ahead from here, all the participants? The next one. Matrix multiplication is distributive over addition or subtraction. So let's say A, B plus C or B minus C. Then you can write it as AB plus minus AC, but that A should be pre-factor. If A is coming from left side, with the product also it should stay on the left hand side only. Yes or no? Give me a quick update. Are you understanding associativeness, distributiveness? But we know it is not commutative. Thank you so much. Great. Now there comes the most interesting fact. I have already told you in the beginning of this session when we were discussing the identity matrix. Do you remember that? Identity matrix behaves like one in the world of matrices, which means if a matrix is multiplied by an identity matrix, it gives you the original matrix. Shall I repeat that, all the participants? Now, here we go with few more things. What are they? Pay attention to this. Yes, this is really beautiful. This is something really interesting. Let's say, I hope in the world of numbers, what do we know? Sir, if you are multiplying two numbers and the product is found to be 0, what do we conclude? Sir, either of them or both of them are 0. I hope you remember in the world of numbers, x into y is 0 if it is given. Then we say either x or y or both are 0. But it does not happen in the world of matrices. What I'm trying to say is, see, this is a matrix which is a non-zero matrix, non-null matrix. This is a matrix which is also a non-zero matrix, non-null matrix. Despite both of them being non-null, if I multiply them, I finally get the product to be a null matrix, all the entries to be 0. So for the product to be null, for the product to be 0, 0 means null, 0, 0, 0, all the entries are 0. It is not necessary that either of them or both of them are to be null matrices. Everybody got this? Shall I re-explain this? So don't assume it by yourself. If the product of two matrices is given to be null, either or both of them are going to be null. No, it is not true. In the world of matrices, it does not happen that way. Everybody understood that statement, yes or no? Similarly, this is happening over here. But let me tell you something really interesting and beautiful. Shall I? Here we are. Let's say I am given matrix A and B are given and their product is found to be null. Both A, B are square matrices of the same order. So what we know is that, sir, determinant of AB is determinant of O. This is O. What is O? O is null matrix. I hope you remember. Here, what is O? O is your null matrix. I hope you remember that, everyone. So I hope you remember determinant can be distributed over product, which means I can say determinant of A into determinant of B. And what is the determinant of null matrix? All the entries are 0. A square matrix with all the entries are 0. Its determinant will be 0. So this is not O, this is 0 here. This is 0 here. Everyone getting this? Now pay attention, everyone. These are not two matrices, these are two determinants. Determinants are numbers. So determinant of A into determinant of B, that is a product of two numbers, which means product of two numbers is 0. What does it imply? So it implies if product of two numbers is 0, which means either of them or both of them are 0. Did you understand what I've just said? What I've just said, that concludes either A or B have its determinant to be 0. First of all, I did not say that A or B could be null matrix. But if their product is found to be null, then it is mandatorily true that their determinants, either of them, is going to be 0. Did you all get this beautiful property with its explanation, or are you still confused? Tell me honestly. Forget the whole derivation, remember the conclusion. It says if two matrices when multiplied are giving you a null matrix, then it is bound to happen that either of them will have their determinant to be 0. Everybody got this, or shall I re-explain? Tell me honestly. That's exactly what we are given, but not the converse. Hitain, if you watch this session from the beginning of this session or discussion, I started my discussion coincidentally with a question on permutation and combination only. The first question we did on matrices today was actually matrices combined with PNC. Watch it, you will beautifully understand how they club PNC, or rather some other concepts. You will start realizing that. Hitain. Now, converse is not true. What is the meaning of converse? Let's say either of the determinants is 0. Then it will not be necessarily true that those matrices when multiplied will generate a null matrix. No, that I did not say. That usually happens with me when I talk to my wife. I have to tell her two statements. One which I'm telling, other which I'm not telling. So in mathematics, we have to be more specific while stating whether converse exists or not. Yes, Alok, don't worry about that. I'll tell you the converse first so that you get more clearly. Let's say determinant A or determinant B. Okay, just to avoid confusion, let's say I know that determinant B has a value 0. We know that. Now, if somebody asks me, sir, does it mean that if A and B are multiplied, it will give me a null matrix? No, it is not necessarily true. It is not necessarily true. That's what I'm saying. Got my point, or shall I repeat it? Everybody with me on this? Although, if this product AB is null, then either determinant of A or determinant of B will be 0. But converse means opposite of it. I hope you remember what we discussed was, if this happens, then this happens. Then converse means if this happens, then this will happen. No, that is not true. Converse means that. I hope you got my point. What is the meaning of converse? Okay, I'll be more specific. Converse means, let's say if it rains today, then roads are wet, yes or no? So there is a statement. This is a mathematical statement, yes or no? So converse of this statement will be, if roads are wet, then it rained today. It must have rained today. That's the converse. If this happens, then this happens. That's your statement. Converse of it means if this happens, then this will happen. So here in this context, converse is not true. If product of two matrices is null, either of them's determinant will be 0. But if either of them having their determinant to be 0, their product is not necessarily going to be null. Everybody got this, or are you still confused? From here, when I move ahead, let's talk about few more properties. What are they? Multiplication of a matrix A by a null matrix is confirmable with A for multiplication, yes, and in that case, it always gives you null. So if you are multiplying A with null, it will be null. I hope you got this. It is absolutely simple, understandable, I think so. With this, I hope you understood this as well. If a matrix is multiplied m times, so that in the world of matrices is written as a to the power m. And with matrices, this property still hold true that a matrix multiplied, let's say 5 times, and that product multiplied 3 times would be equal to the matrix multiplied 3 times and that product multiplied 5 times, or it would be equal to that matrix multiplied 3 into 5 15 times. It is as simple as that. I hope it is understood by everyone. Now, this is the part where a lot of students commit or make mistakes in the chapter matrices. In the world of numbers, algebraically we know a plus b whole square is a square plus b square plus 2ab. Yes or no? Delta star, that is out of your syllabus, but if you really ask me, I'll explain it in the end of the session. If it is needed or if the time permits, or maybe some other day, definitely. But if I ask you a plus b whole square, I'll be writing it as a plus b into a plus b. Yes or no? And if I now start doing it, a into a, that's a square, a into b, that's plus ab, then b into a, that's ba, and then b into b, that's b square. So ba and ab are not necessarily equal, which means I won't be writing it as a square plus b square plus 2ab. That will be false. Got my point, everyone? Similarly, this is how you write this one. This will be ab minus ba. That is also true. I'm really sorry. Let me just check it. Minus ba and plus ab. Yes, that's true. This is plus ba minus ab. That is also true. And this is also true. So I hope all the other properties you can now understand by yourself that why are they not written in the manner the way you might have studied. Sir, if in a question we have to find determinant of a matrix and there is a null matrix present and its determinant is 0, Sapna, be more specific. What exactly are you trying to ask? I'm still confused with the query or concern you are having. Be more specific. If it is a product of two matrices, out of which one of them is null, then product of them is bound to be null. And if you are asking me about determinant of that product, it is going to be 0. Of course, if that is the concern or query you have asked. Now, moving ahead with this, few more things. I think this all I have already explained you. These properties related to symmetric and skew, I'll explain later. Don't worry about that. I want to tell you something very interesting here. This fourth property here. Sir, what is it? Let me take you through that. It is a very beautiful and interesting property here. It is a very beautiful and interesting property here. Now, what does it mean? Pay attention, everyone. What does it mean? Pay attention, everyone. Let's say there is a matrix A, which is a 2 by 2 matrix, and it is a diagonal matrix. Diagonal matrix means what? 2 and 3 are there. Other elements, non-diagonal elements, are 0. Let's say there is another matrix B, which is also a diagonal matrix, which is a 2 by 2 matrix. Let's say minus 1 and 5. Non-diagonal elements are 0, 0. Suraj, I'll record a video on that. I'll record a strategy video on that. You keep watching our videos, stay tuned to our channel. I'll definitely get one video released on this. Rather than putting it in this live chat, you put a comment in the actual comment. It will work as a reminder for me. I'll create one definitely very soon. Don't worry about that. So if I ask you product of AB, please remember, it is really simple here in this case. Just multiply this 2 with minus 1. That's your minus 2. Just multiply this 3 with 5. That is 15. And keep the other elements as 0. You don't have to do that whole matrix multiplication. Even if you do that, you will still get the same product. Symmetric, skew symmetric, I'm supposed to discuss. So right now, I'm not revealing these two properties right now, but I'll discuss. Don't worry. They will get discussed. So I hope so far there is no confusion. Now, there is one more thing. Let's say if I ask you a to the power 5. So a is getting multiplied with itself 5 times. So luckily, what is a? Sir, A is a diagonal matrix. So if A is a diagonal matrix, you need to write it as 2 to the power 5 and this as 3 to the power 5, 0, 0, and your job is done. This is not true for all the matrices. This is true for this matrix only, which is a diagonal matrix. Everyone comfortably understood all what I've said so far? Yes or no? All the participants, or shall I re-explain that? A, B, A to the power 5, everything. With this, when I move ahead, let's solve a question. So this is again a question where I'll be asking you to participate in this poll. If you want to participate, you can download Pylens and you can participate. Sir, how do we download Pylens? Pylens is an application which you can get from Google Play Store, or if you're watching it on your laptop or system through browser, you can download it from Chrome Store. Yes, I get this. You will get complete clarity with a video of mine, which I'll get released soon. Don't worry about that. So if I simultaneously start discussing this question, I am told that there is a matrix A, which is a square matrix such that A into A transpose is identity matrix. Whenever there is a matrix A into A transpose, which is given to be an identity matrix, we call this matrix A to be an orthogonal matrix. So let's say they don't give you this data in the question that A into A transpose is an identity matrix. Rather, what they give in the question is that A is an orthogonal matrix. So the moment somebody says that A is an orthogonal matrix, this assumption should be brought by you that, sir, it means A transpose is an identity. Do you remember A transpose? Rows and columns swapped. So if a matrix is multiplied with this transpose, if it is giving you an identity matrix, it means it would be a orthogonal matrix. Now we are asked the value of this expression. Let me start exploring that. So we are given 1 by 2 and A outside, and then inside A80 square. So A80 square, I hope you know, cannot be simply expanded with that identity which you have learnt algebraically. I'll have to do it manually because I got to take care of the order, because commutative they are not in terms of product. With matrix multiplication, they are not commutative. So I have to be more specific and organized. So what does it mean? This is 1 by 2. This is A outside. I hope no confusion on that. Then A into A, that's A square. Then A into 80. So A80 is identity matrix, that's I. 80 into A, that is also going to be I. Because if A into 80 is I, then 80 into A is also going to be I. So this 80 into A, this is going to be I. Then plus 80 into 80, that's 80 square. Everybody understood my language? Everyone comfortable with what is being done? Then the next part. This A into A, that again gives you A square. This A into 80, that is minus A80. Yes or no? And that minus A80 is again I. Then 80 into A, that is minus 80A. So A80 is I, then 80A will also be I. How? I'll prove it very soon. Don't worry. So this is going to be again I. And the last term will be minus 80, that is plus 80 square. Give me a quick update in the comments. Everybody comfortably understood whatever is explained or done so far? I hope no one is confused. Then the next part, sir. What are we going to do next? Pay attention, everyone. Are you not noticing that these identity matrices will nullify each other? That means a null matrix will be generated. Yes or no? Then the next conclusion is, sir, A square plus A square is clearly 2A square. 80 square plus 80 square is 280 square, and that too is cancelled by this. So technically I'm left with A times A square plus 80 square. Yes or no? When this A is pushed inside, I'm left with A square into A, that is A cube. This is A into 80 square. Can I write it like this? Can I write it like this? Yes or no, everyone? And do you know, or do we know that, sir, A into 80, A was an orthogonal matrix. So A80 is an identity matrix. So can I simply substitute this whole thing by I? And I in the world of matrices behaves as 1. So I into any matrix will be that original matrix, which means now I'll be left with 80 here. I'll be left with 80 here. So let me check. A cube plus A transpose. I think I'm given in option D. That should be the correct answer. Let's see how many of you got it right. So I'm stopping the poll, seeing the results. Okay, so some of you participated and Rohit got it right. That's brilliant, Rohit. Hitin, that's good. I'm glad some of you marked it, and that's brilliant. Perfect. Have you understood the whole explanation, the entire idea? The idea is really simple, just to check your understanding of matrix multiplication. With that, that's brilliant. Good students. That's good gully cricket. Let's move towards few types of matrices. The first one is idempotent. If you see a square matrix, which when squared gives you the same matrix, it is said to be an idempotent matrix. So what is the beauty or importance of this matrix? Now please understand, if by multiplying A with A, what I found was that, sir, A square is turning out to be A. Now, If I ask you what is a cube, so will you not say that, sir, it will be a square into a? Sir, what is a square? A square is already a. So this is a into a, which is again a square. And what is a square? A square is again a. So no matter how many times I find the powers of a, I will always keep getting a only. A to the power 4 will be a to the power 5, a to the power 6, and all the higher powers of a are going to be a only. Yes or no? Yes or no? So here I have told you, first of all, what is an idempotent matrix. Sir, where are we going to use it? You will be using it in the questions. Let's say you're solving a question. You multiply a matrix with itself and you get only the matrix A. And with that, if you keep multiplying it with itself, you will keep getting A only. And this will very beautifully, very quickly, and very efficiently make you solve your question. Did you get my point? If I now move ahead with the next thing, which is called periodic matrix. Now, what is periodic matrix? If there is a square matrix, again, we are doing this whole classification on square matrices only. So if there is a square matrix, I'll be calling it a periodic if a to the power k plus 1 is found to be a, which means, let's say, sir, I multiplied a with itself, I found a square, then I multiplied a square with a, I got a cube, I multiplied a cube with a, I find a to the power 4, and luckily, when I looked at a to the power 4, this I found to be a. This is PW official. You can see my name on an official channel, PW JEE English, Divya. So my name is Deependra and we are from PW official only. It is not fake. Absolutely not fake. So here we are, a to the power 4 is given as a. Let's say it is found to be as a. So there I'll say that I'm reaching to a conclusion that this 4 can I write as a to the power 3 plus 1 as a. So this a will be called a periodic function with its period being 3. With its period being 3. Did you all get this, all the participants, or shall I repeat that? Everybody understood this? And if this k becomes 1, that means a square will be a. So if a square is a, we call that matrix to be an idempotent matrix, as we have just discussed in the previous slide. Yes or no? Sir, where are these things going to be used? Let's have a question and you'll understand it very subtly. How are they used? This question is asked by JEE Mains. They're asking you the value of a plus I to the power 11. Binomial expansion I'll use here. And this is your a. Okay, great. With this, if I now start solving this, I'll say, let me rewrite this a. Of course, we'll start a poll here again and let's see how many of you genuinely, without using AI, with their sincere efforts, crack this question. Shall we do it? Here we are. So I am saying that this is your matrix A. Can I write this matrix as a matrix plus an identity matrix? Can I do so? Can I do so? Sir, why are you willing to do so? Let me do that. And if I am able to do that, I will be in a position to generate something really interesting. Everybody listening and understanding, everyone. Now, here we are. This is your matrix A, which is 1, 0, 0, 0, 4, minus 1, 0, 12, minus 3. So what is an identity matrix? Sir, it is 1, 0, 0, 0, 1, 0, and this is 0, 0, 1. Yes or no? So now I'm trying to think of a matrix which, when added to an identity matrix, generates this matrix. So I hope it is easy and understandable. So sir, here there's supposed to be 1, which I have already taken. So it is 1 plus 0 is 1. So this is 0 and this is 0 because 0, 0, 0, 0. Yes or no? Understandable. Now, this is 0 here. I want the sum to be 0. So I'll put a 0 here. This is 1 here. I want the sum to be 4. So I'll put a 3 here. This is 0 here. I want the sum to be minus 1. So I'll put a minus 1 here. This is 0 here. This is also 0. So I'll put a 0 here. This is 12 here. This is 0. So I'll put a 12 here. This is minus 3 here, but this is 1 here. So what should be added in 1 so that it becomes minus 3? I think it should be minus 4 because minus 4 plus 1 will be minus 3. Everyone, tell me honestly, have you all gotten this? How did I convert this matrix A as a sum of two matrices? Sir, why did you do it? Have patience. There is a standard modus operandi. There is a standard procedure which you need to follow here, which will always get you towards the answer with this category of questions. Now, how do we solve this question? Pay attention, everyone. There, I am treating this matrix as M and I'm treating this matrix as I. If you all are comfortable with that, can we do so? All the participants, yes or no? Can we do that? So now help me in cracking higher powers of A. If you could help me in cracking higher powers of A, my job will be done. But before I start, let me try and help you with this here. Before we do anything else, let's do one more thing here, students. Can you help me with A and its transpose product, or rather, can you help me in finding A square? Sir, what will be A square? This is another way of doing it. Pay attention, everyone. Sir, A is given by 1, 0, 0, 0, 4, minus 1, and then 0, 12, minus 3. And what is A? A was again 1, 0, 0. I'll come back to that method, but let me make you solve this question with one more approach, and then I'll take you through that approach as well. This is how we'll find A square, yes or no? So A square is going to be what? A square, sir, here is going to be 1, 0, 0, 1, 0, 0. That is 1. Yes or no, everyone? Then 1, 0, 0 with 0, 4, 12 is clearly 0. I hope you know matrix multiplication now. Then 1, 0, 0 with 0, minus 1, minus 3 is again 0, luckily. Everybody comfortably getting it? Then 0, 4, minus 1, second row with first column. So 0, 0, 0. So that's 0. Then 0, 4, minus 1 with second column 0, 4, 12. So 0 into 0, 0, 4 into 4, 12, and this is, 4 into 4, 16, and this is minus 12. 16 minus 12 is 4. Okay, something good is happening. Second row, third column, what do I get? 0, minus 4, plus 3. I hope you know the matrix multiplication thing. I repeat, 0, minus 4, plus 3. So minus 4 plus 3 is clearly nothing but what? Minus 1. Everybody comfortably getting what I'm saying or doing here? The next thing, third row, first column, matrix multiplication, right? So this is 0, this is 0, this is 0, so whole thing becomes 0. Then third row, second column, 0 into 0, 0, 12 into 4 is clearly 48, and then minus 3 into 12, that's 36. 48 minus 36 is clearly nothing but 12, and then third row, third column, what does it give me? 0, minus 12, and plus 9. I hope you're getting it. Minus 12 and then plus 9. So minus 12 plus 9 is clearly nothing but what? Minus 3. What have I gotten luckily? Skip that previous method which I was using here. That is not very relevant here in this question. Focus on this method which we have finally cracked or nailed. I hope you all are realizing here we have cracked that sir A square is turning out to be A only. What does it mean? Does it not mean that A is an idempotent matrix, which means A square, A cube, A to the power 4, and all the higher powers of A are going to be A only? Now, let's crack this. I hope now we have A square to be A, which means all the higher powers of A will be A only. Now, A plus I to the power 11, if somebody asks you, what does it mean? I think we have already cracked the answer. Can somebody tell me the binomial expansion of A plus I to the power 11? Can I write that question as I plus A to the power 11? So I hope you remember this expansion. What do I get? I'll get 11C, 0. I to the power, whatever it is I, because identity matrix, how many times it is multiplied, it is always identity. Then A to the power 0. Then plus 11C1, I to the power 10 is I into A to the power 1, plus 11C2, I to the power 9 into A to the power 2, and so on until 11C11 A to the power 11. Yes or no? Everybody got this? All the participants. Tell me honestly. Now, from here, pay attention everyone, the job is done, because here we know, sir, A square is A. That concludes A cube, A to the power 4, and all the higher powers of A are going to be A, because it is an idempotent matrix as we have just discussed. Everyone realizing and understanding the fact here, all the participants. With this, what am I now going to conclude here is a very beautiful result. That's sir, 11C0 I cannot do much with because A to the power 0 is identity matrix. But apart from that, if I take 11C1, 11C2, 11C3 until 11C11, then they all have an A in it. Because this is A, this A square is also technically A, this A cube will also be A, and this even A to the power 11 is also A. So from 11C1 to 11C11, I can take that A common. Yes or no? That's good, Gully Cricket. I'm just supposed to answer that very soon. No confusion on that. Whatever is done so far, yes, little star. Very soon I'll be verifying and validating it. So with this, sir, this has a simple problem here. That, sir, I hope you remember NC0 plus NC1 plus NC2 plus NC3 until NCN is 2 to the power n. But it does not have 11C0. So what's the problem? Can I not add 11C0 here? So let's say here, if I give it an 11C0, if I give it an 11C0, then I'm supposed to subtract it. 11C0 is 1. So I am technically subtracting 11C0 from it, which means I'm subtracting 1 from it, and this is A. And it already had an extra 11C0, which I'm keeping out. I hope you are not confused with that. And this 11C0 should be multiplied with an identity matrix, because this is not merely a scalar quantity. It is a scalar into a matrix. And if there is no matrix, it should be an identity matrix visible here. This expression, is it understood by everyone, or are you all still confused? Now, with this, this is 2 to the power 11 minus 1. This is 2 to the power 11 minus 1 times what? The matrix A plus 11C0 is 1. So this is your identity matrix. Sir, what is 2 to the power 11? We know 2 to the power 10 is 1024. So this is 2048. 2048 minus 1. What is 2048 minus 1? That is 2047. Yes or no, everyone? All the participants. Did you all get this? Sir, now what are we asked? We are asked the sum of the diagonal matrix of that. So we are asked the trace of A plus I to the power 11. So trace of that will be equal to trace of this. Yes or no? Yes or no, everyone? Tell me honestly. Now we know trace is such a beautiful operation that trace can be distributed over addition or subtraction. We did discuss it in the beginning of the session. Do you remember that, all the participants? So with this, I'll say it is equal to trace of I plus trace of this, which is 2047 times trace of A. Yes or no? What is trace of I? An identity matrix of order 3. So 1 plus 1 plus 1, which means this is 3 plus 2047 times trace of A. So trace of A is 1 plus 4 minus 3. 4 minus 3 is clearly 1. 1 plus 1 is 2. So this is 2. Everybody got this? Everybody got this? Now, here we are with our final conclusion. 2047 into 2. That, of course, is going to be 7 into 2, 14. So this is going to be 4054. I'm really sorry, 4094, right? Plus 3. So it should be 4097. Option C will be our final answer. So let's see how many of you got it. Option C should have been marked by most of you. Let's see how many of you got it right. And this time, some of you have participated. That's brilliant. So we have Janvi, Little Star, and Angshuman. Great. Good to have you all. And I'm glad you participated. And I'm sure you have not cheated. You have done it with your sincere, genuine efforts without using AI and all. So have you all understood the logic here? The idea behind this concept here? And how do we solve these kind of questions where it is matrix plus binomial mixed? I hope no confusion on that. Shall I move ahead from here? The next one, the nilpotent matrix. What is nilpotent? When you are talking about nilpotent matrices, let's say you keep multiplying A. And if you keep multiplying A with itself, this A raised to a certain power finally gives you a null matrix. What I'm saying is, A you multiply with A, then you got A square, then you A square multiplied with A, you got A cube multiplied with A, you got A to the power 4, A to the power 4 multiplied with A, you finally got a null matrix. There you need to understand all the lower powers of A before 5 could not give you a null. They did not give you a null. But ultimately, with A to the power 5, you got a null matrix. With A to the power 5, you got a null matrix. So this A, first of all, will be called a nilpotent matrix. There, this K, which is 5 in this example case, will be said or called the, what are we given? There is nothing related to that, I think. But here, a certain higher power of this A, if it is giving you a null matrix, that means it is called a nilpotent matrix. Has everyone understood that, or shall I re-explain that? Everyone, tell me honestly. Then there is another kind of a matrix. Sir, I did the last question by multiplication up to 11th power and I got the answer. Were you really able to multiply it 11 times? Or did you get the generalized result? Do you really have to hit in? Can you not simply just get it with a square? Because a square was found to be a. So there is no point of multiplying a with itself time and again, as we have just concluded with idempotent a cube, a power 4, a power 5, a to the power anything now will be clearly a. Everybody got that? So here we are with the next conclusion. What is involutory matrix? So involutory matrix is if there is a matrix which when squared gives you an identity matrix. If you find a matrix and if you multiply that matrix with itself and luckily you find it to be an identity matrix 1 0 0 0 1 0 0 0 1 in case of a 3 by 3 square matrix, then we call such matrix to be an involutory matrix. Everybody got this, or shall I repeat it, all the participants? Now here, shall I introduce the concept of inverse as well? Because now we may start getting discuss it. What is inverse of a matrix? Please have patience and attend it and watch it with a lot of patience, because we'll be discussing the major part of this chapter now, where we are moving towards that chunk now that all the foundation of this chapter is almost built. We have learned the algebra of matrices. Now we are learning the different operations on which JEE asks you questions. So we are moving towards that part. So there is a matrix A and there is a matrix B, and let's say if I multiply A matrix with B, I find the identity matrix. So there we say that this matrix B is the inverse of A. So this is not a to the power minus 1, which you may call 1 by a. No, it is a symbol. A inverse means, I hope in the numbers what you do, in the world of numbers, if there is 2 and there is 1 by 2, if they are multiplied, you get the product as 1. So that is what we call reciprocal there. So the same concept of reciprocal, if it is brought in the world of matrices, there you see a matrix multiplied with another matrix. Matrix multiplication you must be understanding now. And if that product is giving you an identity matrix in the world of matrices behaves as 1. I hope you remember that. So there, if you are getting this product, you say that these two matrices are inverse of each other. Inverse means when they are multiplied with each other, they give you identity matrix. The way numbers behave with their reciprocals, the same concept exists in the world of matrices as inverse. So reciprocal, inverse, closely knitted. Got my point, everyone? And if you have understood that, I'll get back to this discussion here. Pay attention, everyone. When A is multiplied itself, A square we know is I, which means what? A is multiplied with A, you got I. So the beautiful thing here is that, sir, A is inverse of A. Because what we know is if A is multiplied with a matrix and you get an identity matrix, then you say that that matrix is inverse of that matrix. Did you get my point? So will I not say that A is luckily inverse of A? So that matrix is inverse of itself. If a matrix when multiplied itself gives you an identity matrix, or if in the question the language is given as that there is a matrix which is involutory matrix. So if I am told in a question that matrix X is said to be an involutory matrix, then I'll be concluding it by myself that they are technically trying to say that X is inverse of X. X is the inverse of itself. Did you get my point, everyone? Or shall I repeat it? All the participants. Everybody understood involutory, what is involutory and its meaning. Now transpose, I think we have already discussed. This is what we have discussed in the world of matrices as well. It's simply an operation where you swap rows with columns. So if this is matrix A, which has first, second, third, these 3 rows. And if I convert these 3 rows, I hope you are checking it out. The first row 2, 3, 4, 5. If I convert it into first column here, the second row -2, -1, 4, 8, that gets converted into second column. The third row 7, 5, 3, 1, that gets converted into the third column. Then of course it is nothing but transpose of this matrix. Everybody understood that comfortably, yes or no? Are you getting this meaning now? Transpose means rows and columns interchanged. Simple, straightforward. Shall I move ahead from here? And transpose is denoted by either A dash or AT, right? The next one, properties of transpose. Remember this. Pay attention, everyone. When you take transpose of transpose, it will give you the original matrix. Yes or no? Transpose of transpose means what? You interchange rows by columns. And then again you did the same operation. So what does it mean? You will get the original matrix. Second thing, when you take transpose over addition or subtraction of matrices, then the transpose is such a beautiful operation that it gets distributed over addition or subtraction. I did not say over multiplication, and how that we'll talk about later. But right now, if you are distributing transpose over addition or subtraction, it can be done. I repeat, if you are adding or subtracting two matrices and if you are taking its transpose, or rather you're taking their individual transpose and then you are adding or subtracting, the result will be same. Shall I repeat that? The next thing is, if you multiply a matrix with a scalar and then take its transpose, or you take its transpose first and then you multiply it by a scalar, the result will be same. Is it not self-explanatory? Is it not something which you are already able to imagine in your brain only directly? Because sir, it doesn't matter when you take the transpose of transpose. Yes, you're going to get the original matrix again. You interchange rows by columns and then again you did it. So you're going to get it, the same original matrix. The same thing is happening here. Now, the most beautiful and crucial result is this one. The transpose of AB is B transpose A transpose. I repeat, if you have three matrices X, Y, Z, you multiplied them and then you took its transpose. Of course, conformability was there. So matrix were possible. It was possible to take their product. So conformability in terms of product was there. There, if I multiply them first and then take their transpose, or rather, I take transpose of them and then multiply them in their reverse order. Z transpose, Y transpose, X transpose, it will be same. So transpose was distributable over addition or subtraction, but when it is distributed over product, the order gets reversed. Did you understand my language, or shall I repeat it? When you distribute transpose over product, the order gets reversed. Yes or no, everyone? So I repeat, order gets reversed. Got it, everyone? And I hope it is self-explanatory again. The transpose of an identity matrix will be identity. 1, 0, 0, 0, 1, 0, 0, 0, 1. So if you swap the rows by columns, again 1, 0, 0, 0, 1, 0, 0, 0, 1. It is same, the original identity matrix only. Yes or no? Everybody understood that, or shall I re-explain that? Now, there comes the most interesting part regarding which somebody was asking a question in the beginning. What is a symmetric matrix? Sir, why it became reverse order? Gully cricket, maybe some other day. Today, we have a lot of things. So even in the upcoming slides also, I possibly could be skipping a lot of derivations and I'll be giving you the straightforward facts. Because this is one short revision marathon where I'm supposed to cover a lot, this entire chapter. So I'll be directly discussing the straightforward facts and questions based on that. Will that be okay? Although we have covered it in our batch only in Lakshya JEE in English, I have given you a detailed explanation there regarding everything, behind everything. You can watch it by yourself by joining Lakshya JEE in English. Now, here we are. So what is said to be a symmetric matrix? First of all, in symmetric matrix, you will see whatever the diagonal elements are, skip them, but this element and this element to be same, this element and this element to be same. I hope you're seeing this. And this element and this element to be same. Sir, what do you mean by that? We are not getting it. Can you give us some other definition? Yes, I can. If a matrix is said to be symmetric, and then if you are taking its transpose, it will give you the matrix back. What does it mean? Look at the first row, AHG. If I'm taking its transpose, it becomes the first column AHG. The second row HBF, it becomes the second column HBF. The third row GFC, if I'm writing its transpose, it becomes third column GFC. But when I checked, when I noticed, I saw, sir, AHD, AHD, HBF, HBF, GFC, GFC. So luckily what we found was that, sir, A and its transpose are same. So if a matrix and its transpose both are same, we call such matrix to be a symmetric matrix. First of all, give me a quick confirmation in the chat box. Everybody understood the meaning of transpose of a matrix, symmetric matrix. How do we check it? How do we assess it? Sir, can there be some other definition? Yes, there are three definitions. First one, a matrix and its transpose are equal. Second definition, what you will notice is that these terms pairwise will be same. If it is a symmetric matrix, of course, it has to be a square matrix. Upper triangular equal to lower triangular. Absolutely, absolutely, gully cricket. That's perfect. That's perfect. Brilliant observation. So here, this H and this H would be found to be same. This element and this element would be found to be same. And this element and this element would be found to be same. Sir, can there be some other definition? Yes. Let me take you towards third definition, which is as an extension of this definition only. What is that? Pay attention, everyone. There I'm saying you this conclusion. I'll write it here. If this one, Aij is equal to Aji for all Ij. Hiten, I think I have recorded a one shot on permutation and combination. You can find it in the recorded section. So we have created a playlist there and I think PNC was covered there. I recorded it. So far I remember it. So that should be there. If it is not, someday I'll definitely do it on YouTube for you all. Don't worry about that. Just write it in the actual comment, not in this live chat, that you want a one shot on PNC. I'll probably do it someday. Don't worry about that. I repeat, Aij is equals to Aji, which means A11 should be equal to A11. But if I talk about A12, then it should be equal to A21. If I talk about A13, then it should be equal to A31. If I talk about A22, then it should be equal to A22. If I talk about A21, I think I have already written that. That A21 should be equal to A12. Then if I talk about A23, then it should be equal to A32. Then apart from that, I think, how many? I think now I'll write A31 should be equal to A13, which I have written. Then A32 should be equal to A23, that also I have written. Then next term will be A33 should be equal to A33. That's the meaning of Aij being Aji. What does it mean? Pay attention, everyone. A11 is equal to A11, A22 is equal to A22, A33 is equal to A33. But A12 is equal to A21, A13 is equal to A31, A23 is equal to A32. That's the meaning of a matrix being symmetric. Yes, alternative. There are playlists on our channel only. Have you all understood? When do we call a matrix to be symmetric? First of all, it should be square. Now, three different definitions are there. First one, matrix and its transpose should be same. Done. If not this, then you can apply this. Aij and Ji should be same. Or otherwise, somebody said it, upper triangle and lower triangle. Remove that diagonal, and then if you find symmetry, HH, GG, FF, then it is said to be a symmetric matrix. Everybody got this? Now, if you have gotten this clearly, then the next statement here is something really important. Pay attention. For any square matrix, A with real numbers, A plus A transpose is going to be symmetric. What does that mean? Let me take an example first. There is a matrix A. Let me call it 2, 3, and let's say 1 and 4. What will be its transpose? Sir, its transpose will be 2, 3 becomes first column, 1, 4 becomes second column. What do I get if I add A with 80? So if I add A with 80, I hope you remember 4. Then this is also 4. I'm really sorry, I take a very bad example, but it's okay. 3 plus 1 is 4 and 4 plus 4 is 8. Now I hope you all are noticing this very clearly. What is symmetric? So symmetric means forget the diagonal elements A11, A22. They are going to be same. A11 is equal to A11, A22 is A22. That's not what matters. But A12 and A21 are same. So yes, although I have taken a numerical example, but I hope you can prove this by simple algebra as well, where I hope you are now noticing, let's say there is a matrix X. There is a matrix X which I am taking as A plus A transpose. So there is a matrix A, square matrix, which is added with its transpose. Then I am asking you to take transpose of X, which means A plus A transpose. This is X. So its transpose is what I'm taking. And transpose can be distributed over addition, which means I can write it as A transpose plus, I hope you are noticing it, transpose of A transpose. Everyone noticing it? What is A transpose? Sir, that is A transpose, but transpose of transpose is the original matrix. And with matrix addition, they are clearly associative. So AT plus A or A plus AT, it is same. What is AT plus A? Sir, AT plus A, AT plus A, that means A transpose plus A is X. So this is X. What is X? So transpose of X is X. Is it not following that basic definition that when you take the transpose of a matrix and you find the original matrix back, then it is called a symmetric matrix, which means X will be a symmetric matrix, yes or no? What does it mean? It means a matrix, when added to its transpose, will always give you a symmetric matrix. Hiten is always one step ahead of us. I'm about to come to that point. Don't worry about that. When I talk about skew symmetric matrix, most of your queries will be resolved, especially that query which I think you asked in the beginning, where I told you that I'll clarify this when I talk about skew symmetric matrix. So very soon, I think most of your concerns will get resolved. Will that be okay, Hiten? Now, I hope so far there's no confusion on whatever is told. Now, there is one more property. Maximum number of distinct entries in any symmetric matrix of order n is n plus 1 by 2. This one, I think I have already told you with this basic method, algebraic method, and with this numerical example as well. Are you still confused? If you are still confused, just remember it as a fact that if there is a matrix given to you and you are adding its transpose to it, then forget everything, remember this fact, then it will always be a symmetric matrix. Got my point? I'll come back to my discussion now. Here we are, this one. Maximum number of distinct entries, which means, let's say there is a matrix A, which is, let's say, a 3 by 3 matrix, which is a 3 by 3 matrix. And I'm already told that this matrix A is a symmetric matrix. I'm already told that this matrix A over here is a symmetric matrix. Now I am asked, how many distinct entries can I put here? So first of all, I'll say, sir, I am free to keep these diagonal elements whatever I want. Because A11 is always A11, A22 is always A22, A33 is always A33. Are you understanding my language? Aij should be equal to Aji for a matrix to be symmetric. So for diagonals, it is always already done. So I don't have to bother about these entries. These entries can be anything. I don't really have to bother about them. But then, let's say if I put something here, let's say I'm putting X here. So do you not think that if you had the liberty to choose this X, this element is bound to be X? If I am told that A is symmetric, did you understand my statement and the logic, all the participants? Let's say I chose or took a liberty to choose this statement Y, choose this element as Y, then will I not have to put this as Y only? So I don't have any liberty over here. Let's say I put this element as Z, then this element is mandatorily supposed to be Z. So how many elements could I take independently? So sir, I had the liberty to choose first of all these diagonal elements, and then out of these 6, any 3. Any 3 means either this, this and this, or this and this, or maybe this and this, or something like that. But other one pairwise will be same. So if there is a 3 by 3 matrix, I chose these 3 independently, then any one, upper one or lower one, I could take independently. Got my language? And with that, I think I can develop the logic here. If there is an n by n matrix, so first of all, the diagonal elements, there will be n diagonal elements. Those n you can choose independently. After that, there are total how many elements? Sir, in that n by n, there are total n square elements. Out of which, if I remove the diagonal ones and if I half them, I repeat, there are total n square elements. Out of which, if I remove the diagonal elements, I am left with either these or these. So if I half them, I am left with either this or this. So these are the elements which I can choose independently apart from the diagonal ones, which means diagonal ones are n, and these are the remaining non-diagonal ones which I could choose independently. So these are the total elements which I can choose independently, and if you simplify this, you will ultimately get this as the output. Are you all able to understand and digest whatever I've done, or are you still confused with the concept of symmetric matrices? Tell me honestly in the comment box. Can I move ahead from here, all the participants? Everybody got this? Now, there comes another one about which Hiten will be really happy now. Skew symmetric matrix. Everyone so far, whatever is done, comfortably understanding this? No confusion on whatever is done, all the participants? Let me just have some water and then we'll resume. So just 2 minutes, okay? By the time I'm having my water, you read it by yourself. And somebody quickly tell me in the comments, what do you think? How will it look like, the skew symmetric? Okay, so now let's move towards the next part here. Skew symmetric is what we are discussing now. Pay attention, everyone. So there is a matrix A, n by n means square. So if it is called a skew symmetric matrix, then here A transpose should be minus A. If A transpose was A, we were calling it symmetric. So if A transpose is minus A, yes, we'll be calling it skew symmetric. Sir, what do we mean by that? I am saying you a simple fact here. Please pay attention, everyone. Let's say there is a matrix A which has certain elements. Let's say A, B, C, D, E, F, G, H, I, which is of course a square matrix. Can you help us with its transpose? Yes, we can. A, B, C will become your first column. D, E, F will become your second column. And G, H, I will become your third column. Now, I am told in the beginning of this statement that A is a skew symmetric matrix. If A is said to be a skew symmetric matrix, what I know here is, pay attention everyone, I'll say that A is equal to negative of A transpose, or A transpose is equal to negative of A. So if it is negative of A, let me write negative of A. What is negative of A? This. Now if this and this are equal, I am told A and minus A are equal. A number is equal to its negative. Is it really possible? No. That means A should be 0. Similarly, I am told E and minus E are equal. So if E and minus E are equal, E should be 0. I am told minus I and I are equal. Does it not mean I is also 0? Everybody got this, or shall I re-explain that part? Then, pay attention everyone. Then, minus B and D are same. Pay attention everyone. Minus B and D are same. Similarly, here also D and minus B are same. So second conclusion, D and minus B are related. I hope you're getting it. Then, minus C and G are same. Minus C and G are same. I hope you're noticing. Minus G and C are same. So G and C are related like this. The third conclusion, pay attention everyone. The third conclusion, minus F and H are same. Minus F and H are same. Minus H and F are same. So G and C, B and D, and F and H are related. Sir, what are you trying to conclude with this? I'll tell you a very beautiful picture here. If you could notice, this is how a skew symmetric matrix look like. This is how a skew symmetric matrix look like. Let me just make a correction here. This is how a skew symmetric matrix looks like. Let me just do that. Pay attention everyone. I'll rewrite it in a better manner so that there is no confusion here. Just give me a moment everyone. Let's say there is a matrix A. There is a matrix A which is given by 0, 0, 0. Then its other elements are given by, let's say, H, G here, right? And then other elements are, I'm just trying to create it. Forget this whole slide. I'll just remove it and I'll give you a better idea. Rather than correcting it, let me just give you something else. Pay attention everyone. Let's say we have a matrix. We have a matrix A, which is given by this, which has diagonal elements as 0, this as A, this as B, this as C. So if you are wanting to call it skew symmetric, if it is A, this will be minus A. If it is B, it will be minus B. If it is C, it will be minus C. If something like that happens, you are in a position to say that, sir, this matrix A is a skew symmetric. If you don't believe me, check it out by yourself. A transpose, if you find, what would that be? Sir, A transpose will be 0 AB. then minus A 0C, then minus B minus C 0. And if I take negative common out of it, I hope you're realizing AT will be negative of 0AB minus A 0C and then minus B minus C 0. And is it clearly not A? Which means I could conclude A transpose is minus A. Did you all understand that, or shall I repeat it? All the participants. Are you all digesting it? The skew symmetric matrix? Yes or no, everyone? Another way of looking at it would be this, that if it is a skew symmetric, then principal diagonal elements will be 0, as most of you were asking. The next conclusion is, apart from principal diagonal, pairwise, I hope you remember pairwise, in symmetric we have seen them, they'll be magnitude-wise same, numerically they'll be same, but they'll be opposite in sign. If I could give you a classical example of a skew symmetric matrix, any matrix, if you take, let's say X, I am told this is the skew, which means principal diagonal elements are going to be 0, 0. If this is 2, this will be minus 2. If this is 3, this will be minus 3. If this is 5, this will be minus 5. If you take its transpose, it will be equal to negative of it. Gully cricket, it is equal to negative of it. So another way of writing it is, for a skew symmetric matrix, Aij is equal to negative of Aji. So here, of course, principal diagonal will become 0, because if A11 is minus A11, that means A11 is 0. So A11, A22, A33 will be 0, and they are pairwise. In terms of magnitude, same, but in signature, opposite. Got it or not, all the participants? Or shall I repeat it? Everyone with me on this? So far, is there any confusion? Can I move ahead from here, everyone? With this, if you have gotten a decent clarity on skew symmetric matrix, these are the things which we'll be discussing now. I hope you have gotten this clarity. If there is a skew symmetric matrix, it is going to have its trace as 0, yes or no? Of course, some of the diagonal elements, all the diagonal elements are 0, so some will be 0. Is it self-explanatory? The next thing, if you subtract, I hope I have already explained you, if there is any matrix, if you add to its transpose, it will always be symmetric. So there is one more property. If from any matrix, if you subtract its transpose, it will always give you skew symmetric. If you don't believe me, you can check it out by yourself. I'll give you the proof here, but this is the direct one. A minus A transpose, I am claiming it is a skew symmetric. So for a while, just to make you understand this, let me take A minus A transpose as X. So this is what? This here is X transpose. So X transpose is what? A transpose minus transpose of transpose. So A transpose is transpose, but transpose of transpose is the original matrix. So if I take negative common out of here, I'm left with A minus A transpose and negative outside. So is it simply nothing but your minus X? So when I took the transpose of X, I ended up getting minus X. Does it not mean that X is a skew symmetric? That's exactly what I've told you. Yes or no? Yes or no? It is simply not related to A12 and A21. It has to be with all the other elements pairwise. If they all are same, then it is symmetric. If they are negative but same in magnitude, it is a skew. Hiten, did you get it now? If you have understood skew symmetric and symmetric, I think you got it. Yes, yes, yes. Very, very, very soon we'll be doing a few more questions. Don't worry about that. And you have a question right there in front of you. But before we do it, I'll tell you this property which will give you a crystal clear clarity about this question. All the matrices in this world can be written as a sum of two matrices where one of them is symmetric, other one is skew symmetric. The symmetrical part is A plus AT by 2. Skew symmetric is A minus AT by 2. I hope you're noticing A by 2 will be A. A dash by 2 minus A dash by 2 is getting cancelled. So this is A on the RHS. LHS is also A. But on the RHS, if you notice this A plus A transpose is symmetric. A minus A transpose is skew symmetric. So this is symmetric plus skew symmetric. So all the matrices in this world can be written as the sum of a symmetric and a skew symmetric matrix. got my language. And if you have understood this particular property, let's solve a question now. You can participate in the poll with this, which I have already started. I think it is a timeless poll, yes. But with this, we are taking another 10 minutes break. I hope it's fine. You also take a break, hydrate yourself, take some water, and then, yes, good to have you, Divya. So it is 9:36. We'll resume at 9:46. Is that okay? The class will resume at 9:46. But by the way, meanwhile, if you are done with your break, stretching and everything, come back to this and solve this question and tell me the answer. You can participate in the polls and we'll see how many of you have genuinely and sincerely done it. 10 minutes break. Okay, everyone? Okay, so come back everyone. The break is over and we are going to start with this question. Okay, so we'll talk about the correct answer. That's great. So come back everyone. If you can hear my voice, come back everyone. Sit at your desk, start watching it with again utmost sincerity. Sir, thumbnail. Yes. I'm really sorry. That could have been A1, 1. It is A11. I'm really sorry. Thank you so much, Lokesh, for such a good observation and highlighting it. It might have been a mistake. I'm really sorry for that. So Dhanshu is saying hi for Lakshya JEE. Yes. In our Lakshya JEE in English, this is already over. But yes, you can watch it if you have missed it. Okay, great. Taking transpose simultaneous equation will come and then answer by solving. Okay, we'll talk about that as well. So what am I told here in this question? Let's try and do it. I am told that A is a symmetric and B is a skew symmetric such that A plus B is this, such that A plus B is this. Then what are we asked? We are asked the product AB. Now, have you not forgotten this? I hope you remember it, that each matrix can be represented as a sum of two matrices, where one of them is symmetric and the other one is skew symmetric. It is simply an extension of that property only, which we have just discussed. Forget the whole question. Let me say there is a matrix X which is given by 2, 3, 5 and -1. Yes or no? So if I ask you to write it as a sum of a skew symmetric and a symmetric matrix, how will you do it? I hope you remember. Sir, if I want to write it as a symmetric and skew symmetric sum, it will be half of x plus xt. That will be the symmetrical part of it, and half of x minus xt, that will be the skew symmetric part of it. Yes or no? With this, what do I finally get? I hope now I can conclude it very quickly. That half x plus xt. So what is x plus xt? Can I write xt here somewhere so that I can do it very quickly? Xt will be transpose of it. So 2, 3 becomes my first column and 5 minus 1 becomes our second column. So x plus xt, 2 plus 2, that is clearly how much? 4. 3 plus 5, that is 8. 3 plus 5, that is again 8. And -1 minus 1, that is -2. Yes or no? And if I push this 1 by 2 inside, it will be what? I hope I can do that. If that 1 by 2 goes inside, I hope you are seeing 4 by 2. 4 by 2 is 2. Then 8 by 2 is 4. And 2 by 2 is -1. Everyone comfortably got this, all the participants? Then I'm going to write the skew symmetric part of it. Skew symmetric means half of x minus xt. This is x, this is xt. So 2 minus 2, that's 0. -1 minus -1, that's 0. Then 3 minus 5, that is -2. And 5 minus 3, that's 2. I hope you are seeing it to be skew symmetric, yes or not? And with that, if I push this 1 by 2 inside, 0, 0, -1 and 1. Yes or no? So this will be 0, -1, 1 and 0. Everybody noticed it. This is a symmetric matrix. I hope you are noticing it. Diagonal 4, 4. This is a skew 0, 0, 1 and -1. Yes or no? Which means I hope we were told that this x was actually A plus B. So I think A is symmetric, B is skew symmetric. But sir, what are we asked? We are asked the product AB. We are actually asked the product AB. So I think we are good at taking the product as well. You all know how to find the matrix multiplication now. You have A, you have B. If you are supposed to find AB, you just need to find the product here. So just multiply these two matrices. You know how to do that. So row and column, do you remember that? So 2, 4 with 0, 1 will be what? Yes or no? 2 plus 4, sorry, 0 plus 4, that is 4. 2, 4 with -1, 0. So -2 plus 0. Yes or no? So that's -2. Then 4 minus 1 with 0, 1. So this is 0, -1. And then 4 minus 1 with -1, 0. So -4, 0. So this is your final product. Do we have it given in one of the options? I think it is clearly matching with option C, and I'm sure most of you must have gotten option C as the correct answer. Let's see. Janvi and Likith have got it correct. That's brilliant. So we have other students as well. That's brilliant. Good to have you all. Who are here after the matrix lecture 5 from Lakshya? Okay, good to have you all. Prakhar, the condition was really simple. We have just discussed it in the previous slide only. Here, any matrix in this world can be written as a sum of two matrices where first part is symmetric, other is skew symmetric. What is symmetric? A plus A transpose half. A minus A transpose half is a skew. Yes. Yes, definitely. If you are doing it and if you are getting the answers, which if you are using the correct approach, then it is absolutely great. All of these properties I'll culminate or make you understand with one conclusion only, which is this question. If you understand this question, all those properties could very easily be understood by you. Shall we do it? The question says, A and B are any two 3x3 symmetric and skew symmetric matrices. Now, the moment you read it, what do you understand? Sir, if A is symmetric, we know A transpose is A. And if B is skew symmetric, we know B transpose is minus B. Can I conclude that? So far, everyone comfortably getting this? Then, I am told which of the following is not true. So, I have to go option by option. So, let me read option A. A to the power 4 minus B to the power 4 is a symmetric matrix. Okay, let me say X is given by A to the power 4 minus B to the power 4. So to check whether, there is no short trick, Prakar. To check whether it is symmetric or skew, I'll take its transpose. So if I take its transpose, X transpose will be A to the power 4 minus B to the power 4 transpose. Now, transpose is such a beautiful operation that it can be distributed over addition or subtraction. So, I can write it as A to the power 4 transpose minus B to the power 4 transpose. Everyone getting this? Now, with the transpose and power, you can swap them. That's a property. So, this 4 in T and this 4 in T can be swapped. Which means what? I can write this as A transpose to the power 4 minus B transpose to the power 4. Now, the conclusion which I know here is A transpose is A. So I can write it as A to the power 4. And B transpose is minus B. So I can write it as minus B to the power 4. But minus B to the power 4 will be B to the power 4 because power is even. So it will be received as A to the power 4 minus B to the power 4, which is X. So I began my discussion with X transpose, but I concluded it at X. That means transpose of this is the matrix only, which means this is true. What am I asked? Not true. So option A is incorrect. Everybody got this, or shall I re-explain it? Now, I'll move towards option B. What is option B here? Let's talk about that. But so far, whatever is explained, I hope you are comfortable. There is no confusion on understanding it. How do we check it? Everyone with me on this so far? Now let's talk about option B, everyone. That's great, students. I'm glad you are already doing it. Let's talk about option B. Let's say this AB minus BA I'm taking as a matrix Y. Can I do so? If I'm taking it as Y, I will say what will be Y transpose? Sir, it will be AB minus BA transpose. Now, transpose can be distributed over addition and subtraction. This is not advanced level at all. So this can be written as AB transpose minus BA transpose. Can I do that? AB transpose minus BA transpose. Now, with the transpose, what is the property? We know that transpose reverses the order, which means I can write it as B transpose A transpose. Do you remember that? Minus this I'll be writing as A transpose B transpose. Do you all remember that? Yes or no? Sir, what is B transpose? B transpose is minus B. So this will be minus B. What is A transpose? Sir, that is A. Okay. Then minus. What is A transpose? Sir, A transpose is A. But what is B transpose? Sir, B transpose is minus B. So minus of this will be B. Yes or no? So I got AB minus BA. I got AB minus BA. So if I got AB minus BA, I repeat, if I got AB minus BA, I got Y again. So while taking the transpose of AB minus BA, I got AB minus BA, which is Y again. I hope you are understanding it. Which means AB minus BA is symmetric. And if AB minus BA is symmetric, this is also true, which means option B is also wrong. I'm asked not true. Shall I re-explain that, all the participants? 2 is not the answer. Pay attention, everyone. AB minus BA. So it will be AB transpose, BA transpose. So that is B transpose A transpose. This is A transpose B transpose. So B transpose A transpose is minus BA. And this is plus AB. So this is AB minus BA. And AB minus BA is Y. So Y transpose is Y, which means Y is symmetric. This means this is symmetric. So this is true. But what am I asked? Not true. So I hope you got this. Yes or no? Now, let's check it for option C. Now, most of you must have already cracked it by now, but even if you are confused, I will do it for option C as well. Pay attention, everyone. We are now doing option C. So far, I hope you must have started developing the sense that how are these questions being done. Option C, if I talk about, let's talk about option C. I am given a matrix which I'm calling Z for a while, which is b to the power 5 minus a to the power 5. Let me find Z transpose. That will be b to the power 5 minus a to the power 5 transpose. Now transpose can be distributed, which means it will be b to the power 5 whole transpose. 5 and transpose can also be swapped, and this will be a to the power 5 whole transpose. Then transpose and 5 can be swapped. We have just discussed it, yes or no? And with that, b transpose is clearly minus b, so it is minus b to the power 5. Power is odd, so minus stays outside. A transpose is already a, so it is a to the power 5. Yes or no, everyone? Did you all get this? Yes or no? Shall I repeat it? B transpose is minus b, so it is minus b to the power 5. This is minus a transpose is a to the power 5. But coincidentally, even if I take negative common out of it, it is neither z nor minus of z. I repeat, it is neither z nor minus of z. So if z transpose is taken, it is neither z nor minus z, which means it is neither symmetric nor skew symmetric. And if it is neither symmetric nor skew symmetric, and if it is told to be skew symmetric, then I think it is false. And if it is false, it is my answer because I am asked not true. So I think option C should have been marked by you. Unfortunately, I didn't start a poll. I'm really sorry, but I hope most of you got it. Option C is your answer. Yes or no? Everybody got this? I'm glad some of you cracked it. That's brilliant. With this, I am getting back to this discussion where I skipped these properties with an intent that now, when you receive this entire PDF, sir, how do we have this PDF? By following our WhatsApp channel. The link is given in the description. There, after this session, entire PDF of this entire session will get uploaded. Don't worry about that. So there you will see all of these properties which are not needed to be explained at all, because this question has covered everything which are going to be explained in those properties. But if you want a better structured clarity, I think we have already done it in our Lakshya batch as well. Lakshya JEE in English I'm talking about. And rather, I think this question wholly or completely or thoroughly covers everything what is there given to us. Now there comes the next property, which I think I have already told you. While discussing the question, we were told A into A transpose is an identity matrix. So if matrix A, when multiplied with its transpose, giving you an identity matrix, then we always say that this matrix is an orthogonal matrix. Will you all remember that? Everybody? So there comes something really interesting. Pay attention, everyone. Let's say there is a matrix A. There is a matrix A. I am saying that the matrix is, let's say, A, B, C, D. Getting it, everyone? And then what if I write its transpose? Sir, its transpose will be given by A, B, C, D. Can you help me in finding AAT? I hope you are there understanding what is AAT. Sir, do you have any recorded English batch available on any platform or YouTube? My class Alok Singh is available in pure English. In Hindi is also, it is there on YouTube. If you look for it, you will be seeing it. But in pure English, you can see a lot of one-shots recorded on our channel only. Now, here we are, AAT. So AAT, for this, I'll say if I multiply this with this, so AB with AB, that gives you what? That gives you A square plus B square, yes or no? This AB with CD, that gives you AC plus BD. Then this CD with this AB, that is again AC plus BD. This CD with this CD, it is C square plus D square. Let's say I am told initially that A is an orthogonal matrix. Now, whenever somebody says that A is an orthogonal matrix, I know that it implies that A and A transpose will be an identity matrix. So does it not mean, why did I put a bracket here? I'm really sorry. Okay, so this will be a product here. So this I am told to be an orthogonal matrix. So if it is an orthogonal matrix, A transpose is I, which means this product here will be I. Yes or no? Yes or no? Now here we are. Pay attention, everyone. Pay attention, everyone. I'm going to reach to a very good conclusion. If they are equal, I will say A square plus B square is 1. I will say C square plus D square is 1, and I'll say AC plus BD is 0. Sir, what is the point of discussing all of this? Forget all what I've said so far. Let me take you to a totally different world where I give you a vector, let's say V1, which is given by AI cap, plus B j cap, another vector B2, which is given by Ci cap plus dj cap. Can you help me with the modulus of vector V1? Can you help me with the modulus of vector V2? And can you help me with the dot product of V1 and B2? Vector B1's magnitude will be given by, I hope you know this from physics, under root over a square plus b square. Vectors B2's magnitude will be given by under root over c square plus d square. V1 dot B2, I hope you know component wise it is AC plus BD. Now, if you have noticed something beautiful and if you relate this with this, I think you're reaching to something really beautiful. What do I mean by that? A square plus B square is 1, C square plus D square is 1, and AC plus BD is 0. Have you noticed something really beautiful? Have you noticed something really amazing? Something really insightful? Sir, what are you going to say next is something really, really amazing. What is that? Pay attention. If you ever encounter an orthogonal matrix, if you ever see, what is the role of vectors in matrix? Matrices are actually vectors only. Pay attention, everyone. If there is a matrix, then if this matrix is said to be orthogonal, then the vectors present in them, if you take row wise or column wise and if you treat them as vectors, then they are always unit vectors and they are mutually perpendicular to each other. Did you just listen to what I've just said? I have related vectors and matrices. In the beginning of the session, I told you matrices and vectors are on the same page. They stay on the similar page. So if you could relate them, this is a beautiful exemplification of that statement. I repeat that. If you ever encounter an orthogonal matrix, remember this as a fact. This question, this concept was as it is asked by JEE Advanced this year. There was given an orthogonal matrix. And in that orthogonal matrix, if you understand it, that if there is an orthogonal matrix, then if you treat them as vectors, then they all are unit vectors because a square plus b square is 1, c square plus d square is 1, and they are mutually perpendicular. Did you get my statement? The same conclusion can be brought for a 3 by 3 as well. Let's say there is a matrix B, which is told or said to be an orthogonal matrix. If this matrix B, this is something really important. A lot of JEE advanced level questions can also be done. Trust me, if you know this basic. This is how they use nuances, the basics, the details, the minute details. If I'm told there is a matrix B, which is an orthogonal matrix, where B is given by, let's say, A11, A12, A13, then of course A21, A22, A33, sorry, I'm really sorry, A23, and the next one is A31, A32 and A33. Now, whether you take it row-wise or column-wise, however you wish to take it, you have the liberty to do that. Let's say I have defined 3 vectors here. First vector is A11 I cap plus A12 j cap plus A13 k cap. The second vector V2 I'm defining as B11, sorry, it's not B, I'm really sorry, A21 I cap, then A22 j cap, then A23 k cap. The third vector, let's say V3, I'm defining as A31 I cap plus A32 j cap plus A33 k cap. If these are the 3 vectors, then always remember, if I am told that B is an orthogonal matrix, then without any hesitation, you should be in a position to conclude that vector V1, V2 and V3 all are going to be unit vectors. First conclusion. Second conclusion, they all are mutually perpendicular, which means V1 dot B2, V2 dot V3 and V3 dot V1, they all will give you 0. But sir, after the result directly or by vector answer are same. Yes, you can, Devesh, but I think this conclusion will very quickly give you the result. You don't have to invest your time in doing that V, BT, then I, then all of that. Got my point, or shall I repeat it? All the participants, are you understanding this conclusion? Let's say, sir, you have done it row wise. Can we do it column wise? Yes. Even if I take a vector as this, and this, they are also unit vectors and they are also mutually perpendicular. So this vector dot this vector 0, this vector dot this vector 0, or this vector dot this vector will also be 0. Got my point? Yes or no, everyone? Yes or no, everyone? Everyone got this point? The concept behind orthogonal matrix. Now there is a very beautiful concept lying here is this. If we know that A into A transpose is identity matrix, if A into A transpose is an identity matrix, then can I not conclude that A transpose will be inverse of A? Because if you multiply a matrix by another matrix and if you get an identity matrix, then those two matrices for each other are said to be inverse of each. Yes or no? So if A is said to be orthogonal, its transpose will be its inverse. So let's say someday I give you a matrix. Someday I give you a matrix X, which is A, B, C, D. And I state that X is orthogonal. X is orthogonal. And I ask you, find X inverse. What will you do? What will you do? You will say, sir, don't waste your time in doing anything. Just write its transpose, which is A, B, C, D. That's inverse and that's your answer. Job done. You don't have to go through the whole process of finding the inverse, which is amazingly lengthy. But for that, you need to know that it is an orthogonal. If you don't know that, you will have to do it by the standard process of finding the inverse, which is a little lengthy. We know that, right? Now, this I think we have already covered. So I think we are done. Now moving towards the next part. The next part is singular and non-singular. Something really simple and absolutely easy. Whenever I say that there is a matrix and if its determinant is 0, then we call it singular. And if there is a matrix whose determinant is non-zero, then we call it non-singular. Yes or no, everyone? Yes or no, everyone? So far, I hope there is no confusion on these two terminologies. Now comes the most interesting part. Almost we are reaching towards the climax. So whatever we have understood so far, matrices, properties, adjoint, transpose, different types, transpose, and everything so far, whatever we have discussed, will get clubbed into something which is called adjoint and inverse, and the job will be done. Your chapter will be done. So these last two topics which we are going to study now, adjoint and inverse, are from where most of the questions or majority of the questions are asked. Shall we move towards that? Right now, since it is a marathon, there are a lot of theorems and terminologies and facts, and I'll not be explaining them with proper proofs, which I have already done in the Lakshya JEE in English, because here our motive is to tell you the facts, the statements, and tell you the applications. But ideally, yes, they should go with a logical explanation. Why is it happening and why has it happened and how do we apply it? And that you will understand with more numericals, more problems, more questions. But since we are having this limited time, this one single marathon, where we are revising the theory in a quicker manner with apt appropriate examples, so I'll be a little quicker here. Is that okay? Now, if this adjoint is needed to be talked about, I'll say it's a really simple operation here. Adjoint means a really simple, straightforward discussion. There is a matrix A, square matrix. Do you remember in the chapter determinants or even in the one shot of determinants, we did cover cofactor. So I hope you know how to find minor of a matrix. You know how to find the cofactor of a matrix. Now, once you have found the cofactor, then after taking the cofactor, if you take its transpose, your job is done. That matrix is called the adjoint of that matrix. So what did you just say? Let me repeat it. I'll begin with the matrix. I'll find its cofactor. And once you have found its cofactor, just take the transpose. That transpose will be the adjoint of that matrix. The transpose will be the adjoint of the matrix. Sir, what do you mean by that? Let me take an example so that you get more clarity. Let's say there is a matrix A, which is 2, 3, 4, and 1. This is a matrix A, yes or no? Now, if I take its cofactor, so I'm writing the cofactor of A. So cofactor of A, I hope you remember. For 2, it will be 1. Let me write the minor first. For 3, it will be 4. For 4, it will be 3. And for 1, it will be 2. This is the minor. Now cofactor means A11, so plus A12 minus A21 minus A22 plus. Do you remember that sign scheme we follow? Yes or no? Myronid cofactor, this is what we have studied in determinants. Now, this is what you have found as the cofactor of A. Now, you just need to take its transpose. So, if I take the transpose of cofactor of A, transpose, I hope you remember, rows into columns. So, 1 minus 4 will become here and minus 3, 2 will get here. That's nothing but your adjoint of A. Now, if some of you are very much concerned about the short trick, which I'm sure most of you already know, if there is a 2 by 2 matrix, you can write its adjoint very quickly. Pay attention, everyone. I hope you notice that this 2 and 1 are clearly swapped here. This 3 and 4 stayed there only, but they came with a negative sign. So, it means if there is a matrix X, which is given by A, B, C, D, this short technique is applicable for a 2 by 2 square matrix only. If it is a 3 by 3, you have to go through the whole process. So if there is a 2 by 2 matrix over there given to you, and if you are asked to find adjoint of that, the short technique says, I'm telling you the short technique, which most of you are already aware of, and it is not a short technique anymore because everybody knows it. So there, first of all, swap this principal diagonal element. So this should become DNA, and keep this B and C as it is, just put a negative sign before them. That's how you give the adjoint of a 2 by 2 matrix. Yes or no? Good to have you, Yash. Good to have you. Everybody understood this, or shall I re-explain that? All the participants. Yes or no? How did I take the adjoint of a 2 by 2? Did you all get that? Now, from the chapter determinants, if I take you towards this discussion, where if I now start bringing few properties, the first property states that if a matrix is multiplied with its adjoint, if a matrix is multiplied with its adjoint, it always gives you determinant of A into identity matrix. Sir, how has it happened, or why is it happening? Do you remember a very simple discussion we had? Let's say there is a matrix A. It has elements A11, A12, A21, and A22. Yes or no? Do you remember that? Yes or no? Now with that, I'll say, sir, cofactor of A. Sir, cofactor of A means what? C11, C12, C21, C22. Yes or no? Sir, if I take transpose of this, so if I take transpose of cofactor of A, which means C11, C12, then C21, C22. Sir, what is it? Transpose of cofactor is nothing but adjoint of A. Now, if I ask you to multiply A with its adjoint, not just that, adjoint of A with A as well, then what do you get? Sir, matrix multiplication we know. How do we do that? This is A11, A12, A21, A22. What is adjoint of A? Sir, this is adjoint of A, which is C11, C21. This is C12, and this is C22. Yes or no, everyone? Now, do you remember how do we do matrix multiplication? Sir, rows from here, columns from here. So A11, C11 plus A12, C12. So do you remember in determinants, we did discuss that when elements of any row or column are multiplied with their corresponding cofactors, it gives you the value of the determinant. So A11, C11 plus A12, C12 is nothing but determinant of A. So the first element here is going to be determinant of A. But we do know if elements of any row are multiplied with cofactors of some other row, then it gives you 0. Do you remember that property we discussed while discussing determinants? So this becomes 0. Then A21, A22, I repeat, A21, A22 with C11, C12 again gives you 0. Which part exactly is wrong? Can you be more specific? A21, A22, A21, A22 with C21, C22. So A21, C21 plus A22, C22. Elements of any row are multiplied with the cofactors of that row gives you the determinant of that matrix. So this is that. Yes or no? Now what I'll do next is I can take determinant of A common. So when I take determinant of A common, 1, 0, 0, 1, that's nothing but identity matrix of order 2. That's exactly what I was telling you, everyone. Thank you so much. A dot adjoint of A is always determinant of into I. Although I did not want to explain it, but my instincts just, my instinct just took me with this explanation. But I hope so far, no confusion on this property now. A into, okay, good to have you, Ashlesh. A into adjoint of A or adjoint of A into A will always be determinant of A into I. What's wrong, Gully Cricket? Can you be more specific? I'll explain that, don't worry. But what is wrong there? Can you be more specific? Everybody got this, which means there is one more conclusion. If A is a singular matrix means what? Its determinant will be 0. So if its determinant is 0, 0 into identity matrix will be null matrix. So if you ever see a matrix which is singular, then A into adjoint of A or adjoint of A into A will be 0 into identity matrix, and 0 into a matrix is always null matrix. So this will be O. Tell me in the comment box, have you all been able to understand these two properties? Can I move ahead from here? Yes or no? Then the next part. If you have gotten this part, let's move towards the next property. Again, this one. Ethane 3 by 3, you do it by yourself. The same process. If you don't know this cofactor part, we have released the one shot of determinants before this video. Go and watch it. There in a very detailed manner, I have explained the whole process, the entire process thoroughly in a very comprehensive manner, how to find the cofactor of a 3 by 3. Not just that, minor as well I have explained there. So you'll get a decent clarity. Even despite watching that, if you are still confused, we may do it some other day. Don't worry. I'll dedicatedly record a video for you on this part. Will that be okay? Now, if I am asked to find the determinant of adjoint of A, then it is always determinant of A to the power n minus 1. The proof is here. We have already done it in our Lakshya batch. The entire proof I have given there. So right now, since it is one-shot marathon, I'm skipping that proof and I'm just giving you the whole result, which will be quite useful and beneficial. So how do we use it? Let's say I'm given the matrix A. I'm given the matrix A and its determinant as 3, let's say. And I'm told A is a 3 by 3 matrix. And let's say in the question, I am asked to find out the determinant of adjoint of A. So despite knowing the matrix A, without even finding its adjoint, can we find its determinant? Yes, if you know the determinant of A. The property says determinant of adjoint of A is always equal to determinant of A to the power n minus 1. What is n? N is the order. So what is the order? So order is 3. So it should be 3 minus 1. What is determinant of A? That is 3. So it is 3 square. The answer is 9. Absolutely simple. Did you all get that? Or shall I repeat it? Straightforward property. Will you all remember the applications here? If you want to know the proof, it is given there, which you have already studied in Lakshya. So I hope I can skip that. Something in which IIT is madly in love with is this property. You will see a lot of questions asked on this particular property. How do we apply this property? Let me try and teach you that. Let's say I'm just taking an example here. Let's say I'm told that there is a matrix A which is a 3 by 3 matrix. There is a matrix A which is a 3 by 3 matrix where the determinant of this matrix is, let's say, 5. Yes or no? And then the question says that find the value of adjoint of A's determinant. I think I have 1, 2, 3. So 2 more brackets with this determinant. So you need to find out its value. So the formula remains really simple. The formula says you need to do nothing but just write determinant of A raised to the power n minus 1. So what is n? N is its order. So order is 3. So write n minus 1. So 3 minus 1. And then raise this power. Not the whole. Just raise this power 3 minus 1 to the times adjoint is appearing. So number of times adjoint is appearing is 4 times. I hope you can see. Adjoint is appearing 4 times. So what is 4? In this formula, or as per this formula, this m is 4 here. So 3 minus 1 to the power 4. Because what is n? This 3 over here is your n. Got my point? So what is going to be the final answer here in this case? Determinant of A we have cracked as 5. I hope this whole, not this whole, just 3 minus 1 is raised to the power 4. There is a difference, right? So 3 minus 1 is 2. So answer will be 5 to the power 2 to the power 4. This is not 5 square raised to the power 4. No, this is 5 to the power 2 and this 2 is raised to the power 4. And what is 2 to the power 4? That is 16, I think. So the answer will be 5 to the power 16. Got my point? Have you all understood the property and its application? Proof I'm skipping because we have already done them. This is a one-shot marathon where I'm just giving you the facts, their applications, and how do you use them. Sir, after this session, what are we supposed to do? You should revise this entire PDF, the notes. Sir, how are we going to have these notes? You can avail them at absolutely no cost by checking it out on our WhatsApp channel. The link is given in the description. After the session, we'll upload this entire PDF. Sir, after the PDF, we will be doing all the questions. Yes, all the questions which I'll be discussing here in this, you're supposed to do them. Sir, will that be sufficient? No, absolutely not. Watching this one shot for the chapter Matrices is never sufficient. Then what else is needed to be done? Solve the last 5 years previous year's questions. That will do the justice to your preparation. You still have decent amount of time. Don't take it lightly. Don't take it casually. Don't be careless. This chapter always gives you minimum 2 to 3 questions. In JEE Mains, in advanced also has a huge weightage. So yes, do a sufficient decent amount of practice. 3 questions plus 12 marks. Immensely great in mathematics section, which is considered to be tougher and lengthy in IDJ. Core of maths. It is. So remember it. Now we are told adjoint of AB. That is always taken as adjoint of B into adjoint of A. So remember this. Adjoint, transpose and inverse. Always reverse the order. What do I mean by that? Let's say if I'm taking transpose of ABC, then we did discuss it is CT, BT and AT. The same is true for adjoint of AB. It is adjoint of B into adjoint of A. The same you will find to be true for inverse. If AB inverse is needed to be found, it will be B inverse, A inverse. Will you remember that? So that's how there is a similarity between these 3 operators: transpose, adjoint and inverse. I hope it is not getting confusing. It is not getting heavy. You're able to digest it. And I'm really happy. I'm really glad and I'm really proud technically that a lot of students are still here since the beginning and consistently watching it with great efforts. Really appreciated. Now with this, the next one is, sir, whether you find adjoint of a matrix and then take its transpose, or you take its transpose first and then take its adjoint, it is always same, which means adjoint and transpose are transferable. The same with the power. I hope you remember it. We did discuss that a to the power 5 I'll do, or I'll take its transpose, or I'll take its transpose, or I'll raise to the power 5. It is same. The same is true for transpose and adjoint as well. They can be swapped. So you can take the transpose first and then take adjoint, or you can take adjoint first and then take transpose. It is going to be same. Everybody got this, or shall I repeat it? Now, this is one of the most beautiful properties on which you will be seeing a lot of questions in JEE Mains and Advanced both. Great, great. That's good. This is how you should keep interacting, keep responding, so that it gives us the confirmation that yes, you all are sincerely watching it. Good, Arti. With this, I'll tell you this particular one. This says, let's say, if there is a matrix given to you, which is given by, let's say, 2, 3, -1 and 4. This is a matrix, let's say. Thank you so much. Now, let's say if I am asked adjoint of A. Now, although it is a 2 by 2 very simple example I have taken deliberately just to save some time and just to make you understand the property, but it will be really beneficial and helpful if you are dealing with a 3 by 3. Let's say adjoint of A. What does it mean? Sir, you find adjoint of A first, you'll get a matrix, and then again you find adjoint of that. Will it not be really cumbersome, very Herculean, very time consuming? Then sir, what do we do then? There is a property. What is that? If you are asked to find adjoint of A, the property says determinant of A to the power n minus 2. What is determinant of A? 4 into 2, 8. This is 3. 8 plus 3 is 11. So first of all, you write it as 11 to the power n minus 2. In case of a 2 by 2 matrix, what is n? I hope you see n is clearly 2. So 2 minus 2 it is. I hope you are getting it. So for a 2 by 2, the determinant doesn't matter, luckily. But for a 3 by 3, the determinant would matter. Times A. What is A? Sir, A is A. What is A? That is 2, 3, -1, 4. So sir, is it always going to happen? No. You will not always get the original matrix for 3 by 3. That could be something else. A with determinant A to the power 3 minus 2, which is 1. So this is how you will utilize this property. Have you all understood this? Can I move towards the next slide? Sir, we want proof of it. How did you get it? Here is a proof. I have kept it in the notes. These notes you can avail after this session by checking out our WhatsApp channel. Link is given in the description. The next property. This one, I think I have already explained it. Adjoint of A is determinant. It is determinant A to the power n minus 1 raised to the power m, the number of times adjoint appears. So here adjoint is appearing how many times? 2 times. So m became 2. So this was 2. So this is a corollary of that property. Yes or no, everyone? Now comes another property. What is it? The property is adjoint of Ka. Adjoint of Ka is k to the power n minus 1 times adjoint of A. Got my point or not? Let's say someday I ask you adjoint of 5 times A, let's say, where I know that A is a 3 by 3 matrix. So I can write it as K, which is 5 in our case, to the power 3 minus 1, which is 2, times adjoint of A. So you don't have to multiply the matrix A by 5 and then find its adjoint. You can take that 5 out as 5 square, which is 5 to the power 3 minus 1, and then you simply deal with the adjoint of A, which you know how to. Everybody able to digest and understand all these properties? Yes or no? Yes or no? Tell me honestly. With that, let me move towards the next property. This I think we have already covered. Power and adjoint can be swapped as we do in transpose. So A is raised to a certain power and then you're taking its adjoint, or you take its adjoint and then you raise it to certain power. It is always same. What if determinant of it? Then it is alternative. If you are saying that it is adjoint of, I think I have already done a question on that, but if you are still confused, let's say this is the question, adjoint of A, right? So it's simply nothing, but you just need to apply this. First of all, it remains same. Determinant of A you'll do. Then you'll do n minus 1. What is n? N is the order of A, which means n by n, if it is the order of A, that is n. And then this n minus 1 is raised to a power, the number of times adjoint has appeared. So adjoint has appeared 3 times, so n minus 1 is to the power 3. Adjoint is appeared 2 times, it is 2. Good. That's good. Somebody has responded. Determinant A to the power n minus 1 raised to the power m. Beautiful. M is the number of times adjoint is appearing. Are we clear on that? This is self-explanatory. You can do it by yourself. This is again a very interesting one. This is a general result which will always help you in saving your time in the real examination hall. What is that? If you are given a matrix which is a diagonal matrix, means principal diagonal will have elements, other will be 0. So it's adjoint. You don't have to put your efforts in finding. Even if you do, you will get the same result, but I'm giving you the direct result. It will be A replaced by BC, B replaced by AC, and C replaced by AB, and that's your answer. Job is done. Trust me. Did you get my point, or shall I repeat it? Let's say if there is a matrix A which is given by 3, 2, and let's say 6, and other elements are 0, 0, 0. So of course it is a diagonal. So to find its adjoint, you don't have to go through the whole process, sir, finding cofactor and then its transpose. No. There you write it as simply this 3 replaced by 6 into 2, 12. 2 replaced by 6 into 3, that is 18. 6 replaced by 3 into 2, that's 6. Other elements still remain 0, and that's your adjoint. Your job is done. So that's how you save time with the short techniques. People call them short techniques. They really are not. They are the observations made by a lot of people. Now, whatever we have learned so far regarding adjoint will get culminated with this property, with this question. So again, this is a good question. Let's see how many of you do it. So again, I'm starting a poll here and we'll be discussing it together. Shall we get started? Let's read the question. A is a matrix of 3 by 3. Determinant of A, I'm told to be 5. And I'm given this as something, this whole part. Okay, let me start dealing with this. This is determinant of 2 times adjoint of 3 times A times adjoint of 2A. Okay. And this is how it gets closed. Now I'll just start using different properties. Thank you so much for such kind words. Let's now focus here. Pay attention, everyone. First of all, let me take you towards this property. Do you remember this property? Adjoint of K. Okay, forget that. Not this one. Actually, I need to first of all come out of this. Oh, all right, I'll do it. Pay attention, everyone. Do you remember the one property which I told you in the beginning? Ka. If there is determinant of Ka, then what you do is, we say K to the power, I hope you remember, n times determinant of A. Do you remember that? Yes or no, everyone? This is the property we already discussed. So here, if I use this property, will I not say that 2 into a matrix? So this is adjoint of this into this. A is 3 by 3. So this is 3 by 3. This is 3 by 3. 3 by 3 into 3 by 3 is 3 by 3. So 3 by 3's adjoint will be a 3 by 3 matrix. So ultimately, this whole is nothing but a 3 by 3 matrix. So a scalar into a matrix. If I replace this whole operation by x, so what are we given? 2x. Determinant of 2x, what will it be? 2 to the power n times determinant of x. Everybody got this, yes or no? Just imagine this as x, this whole as x for a while. So it will come, this 2 will come out as 2 to the power n. What is n? Sir, it is 3 by 3, so n is 3. So 2 cube times adjoint of 3a times adjoint of 2a. Yes or no? Give me a quick update. Of course, there is one more bracket. This is what I've got it. How did I take this 2 common or out of this? Everybody understood that, or shall I re-explain this? All the participants. Yes or no? Now what I do next is, pay attention everyone. Sir, I'll be using a property. What is the property? Determinant of adjoint of a. Do you remember that? I think this was our second property. Remember that? Here we are. Here we are. This one. Before this, I think. You do remember it? This one. Determinant of adjoint of a. What is that? Everyone remember that? So determinant of adjoint of a is determinant of a to the power n minus 1. So you can get rid of adjoint with this. I told you an example as well. So if I use that, determinant of adjoint of a is determinant of a to the power n minus 1. So if I get back to the question back, I am showing you these properties so that you can revise them. You can use them because whenever you see the questions, you can use them. So here 2 cube stays outside, but adjoint of, let's say this is a matrix. So we know adjoint of a matrix, and if you are taking its determinant, then I repeat this property, adjoint of a matrix determinant is always determinant of that matrix raised to the power n minus 1. Remember that? It's the same logic I'm using here, adjoint of a matrix determinant. So it will be determinant of this matrix, which is 3a times adjoint of 2a, yes or no, raised to the power n minus 1. Sir, this is a 3 by 3. So 3 minus 1 is 2. Everybody got this, yes or no? Are you all there with me so far? Any confusions on whatever is done? Everybody with me on whatever is being done? Then when I move further, when I go ahead, what do I see next? The next property being applied. What is that? See, do we not know that, sir, if two matrices are being multiplied, you could write them as matrix A into matrix B if their determinants are being taken. So determinant can be distributed over product. This is what we know in terms of matrices. So let's say 3A is a matrix. This is a matrix. So can I not write it as 2 cube outside times this determinant of 3A times determinant of adjoint of 2A. Although there are multiple ways of doing it, but this is one of the ways of doing it. But sir, this has a power 2. So I'll segregate this power 2 like this. Got it or not, everyone? What I did? 2 cubes stayed outside like that. 3A determinant power 2. Adjoint of 2A determinant power 2. Yes or no? I hope there is no confusion so far on whatever is being done. I think now the question is simply this. 2 cubes stays outside. Now this 3A, again the same property. Kx, I hope you remember, is always k to the power n determinant of x. Yes or no? So this is 3. If it comes out as 3 cube times determinant of a. But this whole is raised to the power 2. So will I not say that this should be raised to the power 2 and this should also be raised to the power 2? Yes or no, everyone? Now the next conclusion. What is that next conclusion, sir? I hope you do remember one more property which I have already discussed here. Adjoint of a matrix determinant is determinant of that matrix raised to the power n minus 1. So that logic if I apply here, thank you so much, Yuvraj. I'll say adjoint of a matrix. So I'll say it is 2A. Adjoint of a matrix determinant is that matrix determinant raised to the power n minus 1. What is n? 3 order. So 3 minus 1 is 2. Yes or no? But it is already raised to the power 2. So this whole is raised to the power 2. This 2 is coming out of this 2 and this 2 adjoint gets removed. So you raise it to the power n minus 1. So n minus 1 is 2. I hope so far whatever I'm doing is being understood by everyone. It is not getting confusing. You're not finding it to be a difficult one. You are easily understanding and digesting all what is being said. Yes or no, everyone? Now, I'll move ahead or move further with my final verdict or conclusion about this question. First of all, are you all getting it? There's no point of writing it as 2 square. I can write it as power 4. Can I do so? So I can write it as power 4. Everyone comfortably got this? Now my job is simply this. Sir, can we get rid of this? I hope the same idea. Kx, k to the power n. So final verdict will be 2 cube here. Then this is 3 to the power 6, of course. This is determinant of a square. And this is 2 to the power When 2 comes out of it, it will come out with power 3. So that will be power 3. But sir, it is already raised to the power 4. So power 4 will also be appended. And this is determinant a to the power 4, with which this is 2 cube whole raised to the power 4, which is 2 to the power, I think, 12. 3 into 2, 3 into 4, 12. 12 plus 3 is 15. So this is 2 to the power 15 into, this is 3 to the power 6 into determinant a raised to the power 6. Determinant was 5. So this is 5 to the power 6. This I am given as 2 to the power alpha, 3 to the power beta, and 5 to the power gamma. So if I compare, alpha is 15, beta is 6, and gamma is also 6. So I think it is 21 plus 6, 27. Most of you must have gotten 27, which is option B. Let's see how many of you got this so that we can verify. RD native and Likith. What about other participants? Are you all understanding it or not? All the participants. Hello, hi, good evening, everyone. So our students from our batch have also started turning up here. Good to have you all. So this can be a revision for you all, Jagrati and everyone. So if you are still confused with the chapter matrices, you can watch it. This is the final part. So I'll take a 5 minutes break. I'll have some water and then we'll continue with this. This is the final chunk, the final section. Yes, already done those questions. Brilliant. Great, 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 great. Good. So I'll take a 5 minutes break. Is that okay? This is 12:36. We'll resume at possibly 12:40. So I'll be back by, sorry, it's not 12. I'm really sorry. It is 10, right? We'll resume by 10:40. Will that be okay? So 5 minutes break, then we'll resume. Thank you so much for being so nice, Jagrati. I am a firm believer of keeping complex things simple, not easy things complicated. And it is very wisely said. Genius is keeping complex things easy, not easy things complicated. So as a teacher, it is my job to keep things easy and simple. But if you still feel confused anywhere, feel free to write it in the comments. I'll be happy in clarifying them. But be genuine, be honest, right? Don't spam. Okay, so we are resuming. I hope you can hear my voice. If the screen is there on and you're able to hear me, then come back everyone. Come back everyone. Let's get started. Let's resume it and very soon we'll be able to conclude it. Shall we get started? Here we are. So there we have. Whenever somebody asks you inverse of a matrix, so inverse means what? I hope you had this thing in mind that we have just discussed, that a matrix, when multiplied with its adjoint, it gives you determinant of A into an identity matrix. That logic if I use, I'll say if I divide it on both sides by determinant of A, I'll say it is A times adjoint of A divided by determinant of A identity matrix. For a while, just to keep things simple, say this adjoint of A divided by determinant of A as B. Can I do so? So just to keep things simple, this is A dot B is I. I hope you remember when two matrices are multiplied and if their product is an identity matrix, we say they are inverse of each other. So will I not say that A inverse is B? Sir, what is B technically? B is nothing but what? Adjoint of A divided by determinant of A. So that's how you give the inverse of a matrix. So what does it mean? Let's say someday I want to find the inverse of a matrix. So what is going to be the inverse? Inverse means, let's say you want or you are looking for a matrix, which when multiplied to the matrix gives you an identity matrix. Definitely, definitely. So here, let's say I'm looking for a matrix, which when multiplied to it will give me an identity matrix. So you can very easily find out it by finding its adjoint first and then divide it by its determinant. Got it or not? Or shall I repeat it? Everybody listening and understanding, I repeat my statement. If you find the adjoint of a matrix and if you divide it by determinant of it, it will always be its inverse, which means if this is multiplied with A, it will give you an identity matrix, which in a simpler language can be said like this. Let's say there is a matrix X, which is, let's say, given by 2, 3, -1 and 4. Let's say this is a matrix. How will you write its adjoint? Sir, we already know its adjoint is given by, for a 2 by 2, we know the shortcut. This is a 2 by 2. So shortcut is swap these two. So 2, 4 becomes 4, 2. Yes or no? And 3 and -1, just put a negative sign before them. So -1 minus is +1. So that's your adjoint. Can somebody help me with the determinant of X? What will you say when determinant of X is asked? Sir, you will say determinant of X is going to be, I hope you remember, I can directly write it 2 into 4, 8. This is +3. So this is 11. Can I directly write it as 11? Which means if I now wish to define inverse of X, it will be given by adjoint of X divided by determinant of X. What is adjoint of X? We already know it is 4, -3, 1 and 2. And if it is divided by determinant of X, which is 11, so if I multiply it by 1 by 11, my job is done. Which means I am telling you that X inverse here is going to be 4 by 11 -3 by 11. Then this 1 by 11, you can keep that 11 outside as well, but I'm just giving you 2 by 11. Now, I'm telling you with complete confidence that if you multiply this matrix with this matrix, you are bound to get an identity matrix. Yes, I can say it in a short manner, which means here, this is nothing but inverse of it. I followed the whole process. Everyone comfortably getting this? So that's the point I'm trying to make you understand. First of all, are you all not understanding that when I want to discuss inverse of a matrix, what does it mean? Sir, inverse of a matrix, if you want to bring into picture, that determinant of that matrix is what I'm dividing its adjoint by. So that determinant of that matrix should be non-zero, which means it should be non-singular. So a matrix is said to be invertible, which means its inverse can be found only when it is non-singular. Got my point? Yes or no, everyone? I hope there is no confusion so far on whatever is explained. Shall we do a question with that? So this here will conclude everything regarding whatever we have studied so far. And of course, we'll be discussing few properties as well regarding inverse, and that will conclude. But shall we do inverse based question now? So this is an integer type question. Let me do a poll again and let's see how many of you got it right. What does it say? Although this question, if you want to do, you can do it within seconds by using matrix polynomial, or you may call it Cayley-Hamilton method, or you may want to call it standard matrix polynomial only. That part I'll be skipping in this video. This is the last topic of this chapter, matrix polynomial Cayley-Hamilton, which is not there in your syllabus first of all, but this part will really help in solving a lot of questions with a lot of ease. Although this is not prescribed by JEE, neither for mains or advanced, but this, if you know, you can do a lot of questions very quickly. In our Lakshya batch in JEE English 2027, we have covered it in a very detailed format. So that part I'll be skipping in the end. So this question I'll do with the standard method. But if you know this approach, which I have explained there, you can do it within seconds. But let's do it with the simplest idea here. A is a 2 by 2 matrix such that I am told A is a 2 by 2 symmetric matrix. Okay. So if A is a symmetric matrix, can I not take A as A, B, C? But again, I'm really sorry. A, B, C, but again B here because it is symmetric. So diagonal could be anything, but these two will be same. Yes or no? Everyone, give me a quick response. Now I am told that A into 1, 1. What is A into 1, 1? This is A. Yes or no? So A into 1, 1 means A, B, B, C into 1, 1. I am given as 3, 7. Yes or no? So if I do matrix multiplication here, what will I get? Rows into columns. So AB with 1, 1 is A plus B, which I'll get as 3. BC with 1, 1. BC with 1, 1 will give me B plus C, which is going to be 7. BC with 1, 1. I hope you know matrix multiplication. I don't have to explain it. Yes, there is one more word here, which I forgot. Characteristic equations. So if you are comfortable with any of this, they are same actually. You can do it within seconds. Thank you so much, Jagrati. But if, let's say, forget this, you want to apply the simple idea here, the basics of your matrices, you can do it with that as well. So this is what I've got it. I am told determinant of A is 1. Determinant of A is 1. What does it mean? Determinant of A. What is it? AC minus B square. So I have one more result. AC minus B square is 1. Yes or no? Okay, so now let's work on few things. Which few things, sir? I think we will now solve these three equations. So if I wish to solve these three equations, what I'll do is I will substitute one of the values here. So what should I do? I'm just thinking B, shall I skip? Okay, so I'll substitute any of these values. Let's say from this, I'm subtracting this. So if I subtract this equation from this, I'll left with C minus A on the left hand side, and this 7 minus 3 is 4. So I get one conclusion or relation between C and A, which is 4. Yes or no? Now, I will create this equation in one of the variables only. So let me create it in terms of A. So this is A. What is C? Sir, C can I replace by 4 plus A? I hope you're okay with that. If I replace or substitute C by 4 plus A, are you okay with that? So this C gets substituted by 4 plus A minus B square. Can I say that B here from here can be written as 3 minus A? Are you okay with that? So B, if replaced by 3 minus A, this is nothing but 3 minus A whole square is equal to 1. Everyone comfortably getting all what is being said? Are you all there? Listening, watching and understanding? I hope there is no confusion so far regarding anything, whatever is explained. Yes or no, everyone? Tell me honestly. With this, if I now try and work out 4A plus A into A, that's A square, minus 3 minus A whole square. So 3 square is 9, A square is A square, but of course a minus sign will be introduced. Then this will be minus 6A, so it will make it plus 6A is equal to 1. Yes or no, everyone? With this, what do I get? I think A square are cancelled. 4A plus 6A are 10A. 9 plus 1 is 10. So I conclude A as 1. When I have found A as 1, B I receive as 3 minus 1, which is 2. And C I receive as 4 plus 1, which is 5. So I think I have cracked C, B and A all. So with C, B, A being cracked, I think I will have my matrix. I will have my matrix A. How? I think it will be defined as this matrix A. Yes or no? So if I have this matrix A with me, the job is absolutely done. Are you all there or not? I'm in the flow, just solving these questions and not even looking back. Are you all there? Yes or no? Give me a quick response, everyone. Are you all there? Awake? Yes, Alok. But be more respectful. I'm your teacher. Yes or no? Yes or no? So with this ABBC, right? ABBC. So 1, 2, 5. AB. So AB is 1, 2. AB is 1, 2. So I'll write 1, 2, and then BC. BC is what? 2, 5. So this will be 2, 5. So this is your matrix A. Got this or not? Yes or no? Then I am asked A inverse. I am asked A inverse. So if I'm asked A inverse, we know A inverse is always given by adjoint of A divided by determinant of A. Luckily here in this case, determinant of A is 1. So my final point will be, you just need to find adjoint of A. Yes or no? So if this is A, I hope you all know how to find adjoint of A. For adjoint of A, we have learnt the short trick for a 2 by 2. This is given by swapping this 5 and 1 and just putting a negative sign before this 2 and 2. So it is -2 and -2. Do you remember that? So that's your adjoint of A. Getting it or not? All the participants. So I think I do have my final verdict. A inverse is this. A inverse is this. Yes or no? This is your A inverse. Now, if this A inverse needs to be compared with something, sir, what is that something? This is your A inverse. Yes or no? This is finally your A inverse. Now, if this needs to be compared with what? With this, which is alpha A plus beta A. So alpha A, what is alpha? Alpha is alpha. What is A? A, I think, was 1, 2, 2, 5. So this is 1, 2, 2, 5. Literally, I'm saying this is not what you have to do if you know the characteristic equation. This additional effort you are putting only because you are not aware of this. And this is the final topic which I'll be skipping today. Great, great. Thank you so much, everyone. So with this, if I now continue, I'll say I'll just need to compare a few things. I hope equality of matrices you are aware of. Alpha and beta are needed to be correct, rather alpha plus beta, right? So I'll say this thing here, 2 alpha plus 0 beta, which means 2 alpha. That should be -2. Yes or no? So that helps you in cracking alpha is -1. Then the next thing, I think we need to crack beta as well. So I'll say beta I can put with this. Alpha plus beta is 5. Yes or no? So alpha plus beta, if I know, is 5. Alpha is -1. Beta is going to be 6. So I'm asked alpha plus beta, -1 plus 6. My answer will be 5. And I'm sure some of you must have given the answer as 5. Let's quickly see that. Nobody, no worries. Okay. With this, shall I move ahead from here? Have you all understood this part? All the participants, yes or no? Give me a quick response. With this, we are now moving towards this part. Inverse of a matrix is always unique. What does it mean? Let's say there's a matrix A and its inverse is B. So B when multiplied to A gives you I. So similarly, A when multiplied to B gives you I. So if inverse of A is B, inverse of B is A. You won't say inverse of A is C as well. No, there is unique. They are always unique. Getting it or not, everyone? All the participants, yes or no? The next one, I think I have already explained you. With transpose, adjoint and inverse, the order swaps. The order gets reversed with product. Do you remember that? Everyone. RD native is writing the characteristic equation. I'm glad you know that. Thank you so much. That's brilliant. And these are the few things. Transpose and inverse can be swapped. So if you are taking inverse of transpose or transpose of inverse, both are same, as we have just discussed. Second thing is, even powers and inverse can also be swapped. So you raise it to a certain power and then you take its inverse, or you take its inverse and then you raise it to a certain power, it will be same. Getting it or not, everyone? And of course, inverse of inverse will be that original matrix only. Yes or no? With this, I hope you remember, let's say I'm told that determinant of A is 5 and someday I'm asked the determinant of A inverse. Please remember it. It is always 1 by determinant of A, 1 by 5. This property is a huge one, an immense one, an important one. When you're solving a lot of previous year's questions from JEE Mains and Advanced, you'll be seeing it getting used very widely. And the final property for today. If let's say you're given a matrix, which is again a diagonal matrix, we know how to write it adjoint, the short technique. Similarly, you can write it inverse as well. So what is that? Pay attention, everyone. Let's say if I'm given a matrix X, which is given by 2, 0, 0, 0, 3, 0, 0, 0, 5. I hope you are noticing it as a Diagonal matrix at inverse will be 1 by 2, 1 by 3, 1 by 5, rest of the things being 0. Can somebody help me with its logic? We know it's adjoint. So if you know it's adjoint, you simply divide it by its determinant, you get your answer. Yes or no, everyone? Do you remember that logic? Yes or no, everyone? So I think I have already told you the short technique. For a non-singular of order 2, this is the short technique. And that's where I stop. I end this session. I conclude, I culminate this session. So what are you supposed to do after this session? Go through its PDF. This PDF you can avail by following our WhatsApp channel. The WhatsApp channel link is given in the description. Sir, what was this session about? This session was a complete revision of your matrix session. Sir, is this one shot enough for matrices? Never. You can, of course, get a lot of theory in which I have not covered matrix polynomial. I have deliberately kept it out of your reach because this we have specifically covered when we have discussed it in the Lakshya batch. So that part I have skipped. But don't worry, apart from this you can study, of course. If you are there in Lakshya batch, you will see it as the last topic. Then after the theory, you should go through the questions which are being discussed. Very limited specific questions I have discussed in this session. You should solve the last 5 years PYQs by any means to get a good clarity, consolidation on this chapter, matrices. You have sufficient time for your JEE. It is going to be in January and April 2027. So now don't take it casually. Don't take it carelessly. Trust me, minimum 2 to 3 questions are going to be asked from this chapter, matrices and determinants. That means you can always get 12 marks. In mathematics section, which is lengthy and tough by nature, plus 12 matters most. It is immense. It is huge. 12 marks in mathematics section. So I hope you got this. Practice session you want alternative, I'll try to create one and I'll try to get it uploaded on WhatsApp. So don't worry, I'll try to. Everyone with me on this? Did you get a decent clarity on this? Shall we call it a day? So with that, thank you so much. You have been a great audience. It was really nice interacting with you all. Take care, everyone. Good night.